Yes, good morning to all. So I believe almost all are there on the network. Good morning, all. Right. So I believe today is our revision of all our 14 algorithms and also preparation for the interview questions related to supervised machine learning. And I'm sure you're ready with your doubts because if you would have gone through even superficially over all the notebooks, you would have got some questions to ask, right? So I would keep that first turn for all of you. And there's going to be a lot of question and answers today. So it's not so that I only will raise the question, I only will answer, then there is no use, no? Then it is going to be my practice, it won't be your practice, right? So if you really want to have your practice done, then it is important that you must come forward asking the questions. Okay, right. So at the outset, I'm going to first share a very good GitHub link, which is usually periodically updated in a couple of months once. So please have this link always handy with yourself. This link is not going to give us all the answers, but this link is going to give us all the questions. So we get a direction, we get a very clear-cut direction of how we have to go about. Right. So let me turn on the audios for a few people who are always proactive. Right, and we don't be under the impression that if I have turned on your audio only, then you're going to answer, and then people jinka audio turn on nahi kiya, they shouldn't answer, or they can just be mute, listen to others. No. I want everyone to participate as much as possible. Okay, right. So yeah, Dhananjay, could you please come online for a minute?
Yes, sir.
Right. So Dhananjay, the very first thing which I would like to ask you is that, because I'm sure you would have got time to scan at least a few notebooks out of all the 14 machine learning algorithms which we have finished till yesterday. So your the question which I'm going to ask you is that you have to raise an intelligent doubt for the batch. Out of whatever your learning has been, you have to raise an important question. It may be a doubt in your mind, it may not be doubt in your mind, maybe it's a doubt, it was a doubt and you've already got it resolved, but you'll have to raise that question.
And the main problem is like it's quite a confusion in which case which type of algorithm one should go for. And
Okay, right. So your question is well defined. I instead of putting it on the whiteboard, I would prefer to type it out so that I can have a list of question and answers by the end of the day. So this is Dhananjay's question, right? And Dhananjay's question is when to use what ML, because we don't only supervised till now, so I'll put it as supervised ML algo. Okay, this is your question. Perfect. Yeah, you can mute yourself. So I've got your question. Yes. Next turn. Who would like to take the next turn to raise a question? Remember, your turn does not means only answering. Your turn also means to raise questions. Okay. As I told you, I want interactive class. I want people to raise questions. Okay. Right. So I give the turn to Vinod and then to Sukanto. Vinod, over to you. Vinod, over to you. Vinod, I'm sorry I can't hear you. So you'll have to put your question on the chat, please. Right. Next person, Sukanto, please, over to you.
Good morning.
Yes. Hi. Good morning.
Yes.
Yeah.
Yeah, actually, that my query is little more specific what Dhananjay has raised. That
Okay.
we are having that is in these supervised algorithms. One is that the regression is basically one of the algorithm is a regression where we have the continuous data, and the majority is that the classifications algorithm. So in classifications algorithm, if we start from the basic, there is a naive base. What I understood out of all these things, a naive base that gives a baseline model, and then and top of it will have the different other algorithms, the logistic regressions and
Going correct. Yeah. Till this point, you're going absolutely correct. Guess baseline model barabar hai. Correct. Mhm. That's it. Or like to add something more. Yep, Sukanto, like to add something more, or that's it? Okay. So Vinod, you have risen your hands, please. Go ahead, Vinod. I've already turned on your audio. Please go ahead.
Hello. Are you able to listen to me?
Yeah, yeah. You're very well, very
Okay, okay, okay. Thank you. Uh, Thanks, Rocky sir, for giving me opportunity. First of all,
mhm.
I wanted to. I don't have a specific questions here, but I have a scenario where one of the interviewer given me a scenario, and in that scenario, which is what he has explained me is something like what yesterday you have shared regarding a priori algorithm. So in that case, they what we have suggested is, let's say there is a housewife, and let's say there is a bachelor who is taking a product, and there is those products are interlinked, and that's why we need to combine them, those product, and
Mhm.
put it in the same area where it can be accessible, or we can even generate a marketing strategy for it, or maybe a discounted offer or something like that. So here the assumption is housewife might buy a healthy ingredients, and bachelor might buy beers and chips like that.
Mhm.
So uh, we have a specific customer categorization over here. Like housewife is a specific customer categorization, and
Mhm.
bachelors are a
Mhm.
specific customer categorization.
Mhm.
What we are thinking is, let's say if a bachelor is more educated and
Mhm.
housewife is not more educated for the healthy stuff,
Mhm.
then our assumption totally goes wrong. So in
Mhm.
this scenario, we would be facing lot of false negative and true negative and false positive. So
Mhm.
how to handle such situation, and which are the algorithm which are suitable to generate specific equation to cater such kind of a targeted audience.
Mhm. Mhm. Okay. Anything more you like to add? सोचिए थोड़ा सा और कुछ ऐड कर सकते हैं.
Yeah, I have given a reply like we can generate a marketing customer specific marketing. So let's say if I am combining those particular products which are related to housewife, then
Mhm.
I will only do such marketing activity where the housewives are involved, and we will not call bachelors at that particular campaign. And after
Mhm.
the campaign finish, I will generate one more campaign for the bachelors, and that is how I would given a reply. But I don't think so that that is fitting into our whole model based situation.
Correct. No, what answer you gave was correct, but it was from the marketing perspective. It was not from the data science perspective.
Right, right,
Hmm. It is not using the data actually per se.
right.
Okay.
So how to handle such situation as per data science perspective?
Hmm. Understood. Understood. Good. Good. Also, if it is educated ambassador is more health conscious. I have gone wrong with the spelling of conscious. You just punch me the spelling of conscious on the chat. I'll just copy paste it here. Okay, Vinod. Yeah. Right. So Vinod has come out with a question. Dhananjay came out with a question. Dhananjay's question was partly answered by Sukanto, and that is always impressive because Sukanto is always volunteering, ready to help me and others always. That's his very positive quality, which brings him out of the whole batch. Very nice. And I'm wondering how come Atnu has not asked me a question. I'm wondering on that now. Atnu ने सवाल क्यों नहीं पूछा
No,
मुझसे?
no, Rocky sir. Yeah, I am about to ask you one question. So,
Yes.
we have
So,
one
hold on, Atnu, a second. So these people, Atnu, Kavita, then Ashish, Arvind, ये मतलब अगर मेरे को सवाल नहीं पूछेंगे ना तो मतलब मेरे को आज खाना हजम नहीं होगा. So so if you want me to eat my lunch, then please make sure you are asking me questions. I hope you all get me on this, right? Yes. नहीं कविता मुझे कुछ नहीं चाहिए आपको ऑडियो पर आना पड़ेगा और सवाल पूछना पड़ेगा सोचो आपके पास टाइम है आपका टर्न आते आते 10 मिनट हो जाएगा यू हैव टाइम टू थिंक अबाउट इट ठीक है यस अतनु ओवर टू यू आई एम सॉरी टू इंटरप्ट यू ओवर टू यू या अतनु ओवर टू यू
hello, am I audible?
yes now you're clear
Yeah. So we had one assignment that is for income analysis, qualification analysis. Okay. So in that assignment, actually, there was close to 145 features is there. Okay. So actually, see, all the 14 or 14 algorithm, whatever we have done, along with all various kind of example. Okay. So we are not handling that much of actually number of features, right? So I mean, so I think if it would be better. So if you can actually, try to understand that how to deal with that huge volume of, data set. In terms of the number of columns or features. So that would be great help actually.
Perfect. Understood. So the question is there was some assignment you were solving which had 145 columns, 145 features. Your question is how to reduce the features.
Yes, how to reduce and how to handle. Yeah.
I should say how to choose the most apt features. Am I right? This is what is going on in your mind?
Yes, sir. Yeah.
Cool. Right, 3 more participants have raised hands. Sai Venkatesh, please. I'm very happy you're coming online. Please, over to you. Oops. Sorry, Sai Venkatesh. Yes, it got interrupted.
Okay, sorry.
Yeah.
Am I audible? I'm speaking on through phone on mobile. So basically we'll be having some disturbances. Sorry to hear that.
Yes.
Okay, my question is to extension of Dhananjay. Like once we started with one of the requirement, like we just had a problem statement, but nothing else. So we start with implementing one algorithm after the algorithm and the other algorithm during the starting stages. Okay. So when should we stop that? Like how many algorithms or when can we say that, yeah, we can go to this model or we can fix with this model or we have to we have to try with other new models?
So are we trying to say when should we stop trying different models over our data?
Yeah.
Okay. Sure. Understood. Anything else you'd like to add to this, to your question? So that, once my question set is ready, then, then as a sincere student, I can go on answering, because once the test paper comes from your side, I will be in a position of connecting the dots of what is going on in your mind psychologically. So that I can answer them all together in a continuous flow. Yeah, sure,
And
understood this.
one more basic question, Rocky.
Yes,
Sorry.
yes, please, yes.
Like when we get any problem statement, okay, so how to analyze it? Any tips? I would like to have some tips on that. Like this is the things we need to look into it.
Okay, so you're talking about pointers to analyze a
Yeah.
problem statement.
Yeah.
Understood. Cool. Great. Yes, other people have risen hands. I'm coming down to you all. Yeah, Vinod, your audio is on. Please tell me. Okay, no problem. Arvind and Jayvan both have risen hands. So could I take? Let's go with Jayvan first, and then Arvind. Jayvan, over to you. Jayvan, over to you. No response. Okay, no problem. Arvind, over to you.
Good morning, sir.
Yeah, hi, good morning.
So I have few questions actually.
Please tell me. A few questions. So I would put your name out over here. Yeah, please tell me. But ensure that questions are not repetitive of what people have asked about.
Yes, I understand. So as we have been asking there which model to use, but my question is which kind of error to look for while creating an ML model. How to check which kind of error we should look for while creating an ML model.
Correct. Hmm, hmm. Yeah.
The other question I have is how to modulate random state to get better result. As we have seen that tweaking random state a bit can give us better results.
How to simulate random state to get better results. Yeah, to get better results.
And so the third question I have is how to decide or modulate the test train size to get better result, because we have been taking like 20%, 25%. At times we have taken 30% as well, 30, 70.
Correct. What are the
So
best test size? Huh?
yes, sir.
Correct. Take it. Or best train test size.
Yes.
Perfect. Good. Okay. Anything else?
Not now, sir. That's all.
Okay. Okay. Cool. Uh, yes. Jayvant, you have again risen your hands. Please come on audio. Jayvant, if you're not able to turn on your audio because of some technical problem, you can please post your question over the chat. Okay. I go to Kavita. Kavita, over to you.
Yeah, good morning.
Hi. Good morning.
Yeah, I have general question now. Probably it may be answered, but just rephrasing that. Now we have generated models. Of lately we have generated, we have worked on various models, and we have reached with the best fit model where we get 80%, 83%, 79%, yeah, whatsoever percentage we have arrived. But suppose that in most of the cases we would have stopped at getting the arriving. But then I want to test how do we again apply it on new data. Now, for example, bill authentication. We received one model where 80% we met. This model is working, is able to classify rightly. But then when we have new set of in logistic, I think in one of the cases we have seen when we take new cases and then we how fit and we how is it actually working on the new datas. But similarly on regression model or any other random forest, whatever we have done, so that one has a how do we imply on new set of records once we have arrived at the percentage is my question. Second question is this is very general. This is pertaining to me probably. Sometimes what we have a good understanding of the problem statement. We understand very well like what is we required to do. But we get on to coding, we lose everything. We just go upside. When we this is domain. Where with domain knowledge you're good, but when you apply it on with Python and coding, you lose the track. So that's one. And the third question is when we split the data, we have seen that sometimes we go with 80-20. That's the Jayvan's question, I guess. Last he said when we go 80-20 or whatever test and train. But instead of this step, we can directly go into cross validation where, you know, the entire set is, you know, that, from each set training is being, so can we go directly on CV approach? So that's my question. Yeah.
Correct. Yeah.
Thank you.
Understood. Yes. Anybody else with some corrective questions? Don't get frightened. Arey, इतने सारे questions तो आ गए. Don't worry about it. All these questions will get covered in about 1 hour 20 minutes on clock. So if you have only 1.5 hours. So if you have other questions, please ask. Any question which is coming to your heart, you can open Google and blog and go on reading and then ask me the questions. I don't have a problem. Anything that is coming to your heart or your mind, please feel free to ask. Because the next such session is going to be only after our unsupervised ML algorithms finishes. That means after maybe 2 or 3 weeks. So I don't want the questions to get piled up. You know? Yeah, Sukantu, you raise your hands. Over to you, Sukantu.
One question is that how to see the biasness in the data in the given data set.
Sukantu, you'll have to go once again. Your question once again.
Yeah, how to check that the biasness in the data? If there is any biasness in the data.
Bias and variance are interrelated. So how to check the bias and variance in the model? In the model, it's not data. In the model. In the model which you have made over the data, of course.
Right.
Okay. Sure. Anything else, Sukantu?
No, sir.
Okay, cool. Fantastic. Right. So the reason why, Sukantu, just a second. The reason why I'm asking you the questions beforehand is because I know how I'm going to arrange them in the ascending or in descending order to answer your questions. Okay. See, right now the questions are coming at an individual level with an individual mindset. हर इंसान अपनी तरफ से क्वेश्चन पूछ रहा है. आपको ये नहीं मालूम कि आपके पीयर ने क्या सोचा है और उसने क्या सोचा है. So I am, but as a trainer and knowing what student psychology is or knowing what is going in your mind at this point of time, I'll be able to rearrange it and make it like a storyboard. So the moment I make it like a storyboard, I will have all the dots interconnected and you all will get a holistic picture from your peer questions. Try to understand what I'm trying to say. So right now, every individual, like you're not doing peer, there's no peer contribution here. Like for example, Kavita didn't add any knowledge to Dhananjay didn't add any knowledge to Sai didn't add any knowledge to Vinod. But you have asked your questions. As a trainer, as a focal point, as a mentor, my job would be to arrange them in a proper order so that I create a storyboard out of it. And once I create a storyboard out of it, usually when we have to present to the management side or to the business side, we always create a storyboard, right? So we create a storyboard and we present it. So that helps. So then Vinod will realize कि जो सवाल उसने पूछा वो सब लोगों को help कर रहा है. अभी वो उसका सवाल है. But if I answer his question, it's going to help. No. If you make a storyboard out of it, then obviously it is going to help everybody else because everybody else will know, oh, thank God Dhananjay ने वो सवाल पूछा. मेरा भी वो क्वेश्चन आंसर हो गया. मेरे पास तो वो सवाल पता ही नहीं मुझे वो सवाल था. आपके सबकॉन्शियस माइंड में था कि आपको वो डाउट है, लेकिन आपको ये नहीं पता था कि आपको आज पूछना है. That way. So anything which your heart saying, please let me know now. It will be difficult for me once my storyboard mind is working. My mind works at a different level. So I'm thinking how I have to arrange this question. So if you have anything else, please feel free to ask. So I'll know where to put that. Okay. Arvind has again risen hands. Arvind, over to you.
So it's not a question, but some help we'll need. Sir, can you provide us a link where we can get question and solved answers of ML method models?
I just gave you the GitHub link, which is meant for interview questions.
No, sir. So I'm asking where we'll get a sample of like models which is built there, like questions in the models, so that we can have better.
There is no such GitHub link. Neither there is anything. But if there are, there's a lot of scrap in it. So I would not advise you to figure out any particular link where you're going to have all the models in place. ऐसा कोई link ही नहीं मिलेगा आपको. It's going to be infinitely very large, where you will have a model made and the questions on the model asked and answered. No. There could be a place where only questions are asked and only thrown, which is like, it's like scrap. So uska kuch sense nahi banta that way. But the GitHub link which I have shared with you generically has all the steps which are needed for the kind of question which you, and plus there is another link on our website also. The company for which I work, even they have a link. You can look at it. It's swingconsultants.com, datascience.swingconsultants.com, interview preparation. So maybe that helps you. I don't know if that helps you. If that helps you, that's nice. I'll be happy. Just a second. Although, again, this is a generic opinion on this page, interviews. Maybe this also helps you. So there will be two links which are going to help you. One is of this GitHub link which I've given you, and second. But yes, I'm 110% sure there is no such website or blog which is having all the algorithms. Then you'll have to look for Jason Brownlee. But there are so many blogs he's written, so many. मतलब वो 100 blogs पढ़ने से तो better है कि आप हमारे 15 से 20 notebooks कर लो. कितने पढ़ोगे कितना पढ़ोगे? ऐसा है.
Sir, actually my question was कि ऐसे मतलब कोई साइट जहाँ पे ना we can see these questions and उसका solution भी हमारे पास था.
नहीं मिलेगा आपको, नहीं मिलेगा. वही बता रही कोशिश कर रहा हूँ आपको नहीं मिलेगा. So one of the best GitHub links which has sensible questions and sensible right answered ones which I have shared with you maybe 2 or 3 minutes back. I don't know आपको मिला क्या वो link? GitHub का link मैंने जो
share. हाँ सर मिल गया सर.
हाँ. ऐसे बहुत सारे GitHub के links हैं, but then there are a lot of scrappy questions asked there. For the purpose of just to get hits, they have asked the questions there, which is not technically correct. And they just posted the questions. आंसर्स नहीं दिए, बस क्वेश्चन पर क्वेश्चन डाल दिए और उन्होंने लिंक्स दी हैं टुवर्ड्स डेटा साइंस एनालिटिक्स विद्या. तो फिर घूम फिर के तो वही होगी बात कि वही 25 क्वेश्चन डाल दिए, 25 ब्लॉग लिंक्स देते, 25 ब्लॉग बंदा पढ़ते बैठे उससे बैठे तो वो 15 नोटबुक कर ले. ऐसा है. ठीक है.
Thank you sir.
Yeah. So friends, now
Rocky, one more to add to your list.
Yes. Is it Sai Venkatesh?
Yeah.
Yes, tell me.
Rocky, like for which type of data do we need to use which type of algorithms?
So you're trying to talk about data, any like you want to map data to the model.
Yeah, I mean, if it's like like we'll be having on different features, like on marketing or on the usage statistics or on some other things like on different domains, if you think like which type of data will be model will be helpful for those types of data.
Correct. Understood. Just give me a second. I'm just doing my space management a bit. What will happen? This file I will punch it to Rohan on the chat and he will punch it over the Google Classroom later, so that none of us have to type. We can only concentrate on the work right now. Okay, so let's see how this can be arranged. Atnu's case is the first one.
Sir, Srini here.
Yeah, Srini, please tell me.
Okay, so sir, I'm like I have a one question. It's almost covered to Dhananjay question. But just thought of ask you, like in different way. As he asked him like which model we need to be used, and my scenario here is like we received one like a problem statement from the business requirement.
Okay.
From the business, we verified the data and we read it. And in the data, first we'll verify if there is any null values are present or not. If there are null values, okay, we are good. Our data is good. We are good to start. So in case if we have some few null values, I mean, like how we can decide whether we need to be delete those records or we can keep it those records. If we want to keep those records, either we need to be substitute with either I mean like a mean of the values or something like that.
Okay.
And
So you're talking about strategy for null or strategy for handling null or NaN values.
yes, values in the given data. And we are talking about 14 algorithms. And like, sir, I mean, like, frankly speaking, I mean, like, I missed out a couple of your sessions. So if you don't mind, I mean, like, just, I mean, like, tell me those 14 things, algorithms, at least names only. I'll go through it. And
वो तो वीडियोस में हो गए, I don't know. अभी LMS सिस्टम में वीडियोस अपलोड होते हैं ना सब टाइम टू टाइम.
Yeah, I'll refer those videos, sir.
नहीं वो तो मैं बताऊंगा आपको, but what I'm trying to ask Srini is that I do not know ना. See, I'm asking you, are the videos uploaded or not on the previous session? They are uploaded, no?
Yeah, uploaded, sir. Yeah.
Yeah. So I will definitely tell you 100%.
14 algorithms.
Algorithm
And
done
one more
of supervised category.
And every time I'm like we need to be I mean like try different algorithms, sir, every time, or like we'll try I mean like even in the real time scenario also. Okay, we are trying this algorithm 1. Okay, we got 60% of the accuracy. We are trying the algorithm 2. We got the 62%. Then we tried the algorithm 3, 68%. So out of 3, okay, 68 is somewhat I mean like a best accuracy. So we are proposing this model. But this taking I mean like a little time, no, sir. I mean like algorithm 1, algorithm 2, and algorithm 3.
So are you trying to say that in this question of Dhananjay, when to use what ML, supervised ML algo, are you also trying to probably ask that from which algo you will wish to start with, like some tips to start with something?
Yes, sir. Yes, sir. I mean like, yeah.
Okay. Tips to start with which algo? Okay, please excuse me on my English, Srini, because my English may have gone wrong while typing quickly. Right, tips to not start it, shortlist. Tips to shortlist.
And in supervised learning, we are I mean like classifying into regression and classification, sir. I mean like when to use regression and when to use classification.
That too, I think I don't know, but किसी का सवाल था वो. Somebody's question was there, which was matching with that. Dhananjay's question in front of you. Oh, don't worry, that will be taken care. That will anyway will come while I'm explaining this.
And when I am like refer this like sir, a single variant, multivariant, and bivariant is all comes under supervised learning, sir?
No, they come everywhere. There are types of variables. Univariate, bivariant, multivariate are types of variables. So they will come everywhere. Part of statistics, no? It's common to all. The types of data. There's nothing to respect to model. There are types of data. Models can handle univariate data, bivariate data, multivariate data, but our models almost can handle all types of data now. Okay, right. So I believe the last 30 minutes you gave me awesome inputs. Now my turn to give you awesome inputs for the next 2.5 hours. Okay, so let me start with the very first question. And if I misunderstood somebody's question, whoever has raised it, for example, if Atnu has raised it, and if I misunderstood something, you are welcome to add on to it or correct me there. Okay, Vithal, you even raised hands. Yeah, please, Vithal, over to you.
Hello, sir.
Yes, hi.
Actually, it is a general question. I am from automotive R&D industry.
Okay.
I have non-programming background, though I still join this course.
Right.
and want to pursue good opportunity in this field. So as a non-programmer, I find more difficulty to get knowledge or to get running code. So I want to just ask you, in order to make good or master in this programming or coding field, please guide us for that.
Correct. Understood. I think a very similar overlapping question was from Kavita also, where she said that problem is very well understood. So in both of your cases, you are domain experts, but when it comes to Python coding or in generic for any kind of coding, you get confused what to do, like blank out.
Yes.
Understood. Yes, I will answer this 100%. Yeah, Srinivasan has asked the next question. Srinivasan, I'll put this question of what is underfitting and overfitting out there in your. Where is your set code questions? Where is that code? Shini kidhar gaya? Haan. Shini, you've asked 3 questions over here. Okay, list is comprehended. But I believe Nitin is the last person who's risen his hands. Nitin, over to you.
Yeah, hi Rocky. Can you hear me?
Yeah, very clear.
Yeah, actually my question is when we consider huge data when having lot of features, so what are the things we should consider to dropping unwanted features to means improve our model?
Okay. Nitin, your question actually exactly overlaps with Atnu. So I'll put Atnu and Nitin together. Okay?
Okay.
Yeah, sure.
Even Rocky, I have some question in the chat window. Okay.
Who is it? Usha Kiran? Kiran? Yeah. So hi sir, if we get raw business data, can you please tell how to organize and use it for analysis? Yeah. So Usha's question overlaps with Shini's question to a certain extent. So Shini and Usha Kiran here having a similar question. Plus your question also overlaps with one more. Wait. Somebody had asked me for cleaning process. I don't remember who had asked. Let me see. Just give me a second. Okay. तो यहाँ पर नहीं है. ठीक है. So let me put another thing. State. ठीक है. Usha Kiran taken care of. Yes, Prasun, should I turn on your audio so that you can come on audio? Because Prasun. Yes, Prasun, over to you.
Hello.
Yes, Prasun.
Good morning, Rocky sir.
Good morning.
Actually, I have a query related to when I was studying this XG booster. I found out a question which is what is a light GBM tool?
So you know what is GBM, by the way? There's a gradient boosting, no?
I don't know about it.
Okay. So anyway, so it's basically a modified version of it. So I don't mind answering that particular question of it, but then ultimately it's basically a gradient boosting framework, which is very similar to your decision trees which you have used, but it is basically a lighter version of the XGBoost.
Okay.
So what XGBoost can do, the same thing can be done by a light gradient boosting model also, but it does it in a much quicker way, but it is less accurate also.
Okay.
Yeah, so basically it is a lighter version of XGBoost. XGBoost at times on large data takes too much of time to get trained, and it exhausts a lot of memory. So the system actually hangs. जैसे मैंने कल बताया था website behavior, आपको याद होगा?
Yeah.
तो XGBoost मैंने use किया. तो XGBoost regressor took about 1.5 hours. I got frustrated. I had to end my session.
Okay.
So if I would have used light GBM, I although would have got a dent on my accuracy, but then at least my work would have got done.
Okay, so that's why we are not covering this topic. because it's not
It is the
useful.
same thing. It
Yeah,
is the
yeah,
same as
sure.
XGBoost. There is no difference. Only thing you have to make an object of light GBM. That's it, and it is fast in training. It is low on memory consumption, and it is computationally. मतलब आपका CPU थोड़ा सा कम power लेगा वो. And at times on large data sets, in fact, light GBM gives a better accuracy than at times than XGBoost. So
Okay,
nowadays
thank you.
people on large data sets straight away go for using light GBM. They don't use XGBoost. If the data is very large, they will not use XGBoost. They will time बहुत लगेगा, so they don't use it at all. Right? Yeah.
Yeah, thank you, sir.
Sure. Yes, Srinivasan, you have raised your hands once again. Is it by mistake?
Yes, sir, it's by mistake.
Yeah, sure. Okay, so now, friends, please allow me to go ahead to answer the questions. Okay, so now I will not take questions. Now I will do the discussion, and I will going to call upon people of what they have understood when I explained them in brief about their question. Okay, so Atnu and Nitin came across some assignment where there were 145 columns or 145 features, very big number. I agree. The obvious question that will come to their minds are, how do I reduce the features? See, there are two ways to reduce features in globally in any machine learning problem. One is called as feature selection, and other is called as feature extraction. In feature selection, how would you go about it? It's super simple. You're going to first do exhaustive EDA, PCDA वाला course, जो उसके पहले कर रहे थे. You're going to do exhaustive EDA, exploratory data analysis. You may not do EDA only by using Python. You may not do EDA only by using Python. And yesterday, post the lecture, one of the participants from this batch just, we just called me and we had a detailed chat, and he was doing awesome work. He's from a non-coding background, but I think what kind of work he's doing, a counterpart IT person would be doing in a company like TCS or maybe an Accenture. So, and he was doing exhaustive EDA. So EDA can be done in Excel. You could use Tableau. You see, you to basically explore data analysis means you have to get the business intelligence out of your data. You have to mine it, nothing more. Or you could use Python. Because we are learning Python, so we say we have to use Python. But there's no hard and fast rule that it has to be used done by Python only. In fact, many times you make an entire application in Python for EDA, you could have might as well done it much quicker by using Excel. So even if you have an Excel expert, even if you hire an Excel expert and tell him कि मुझे ये चीजें करके चाहिए, I want to get these Excel sheets made and these scripts written inside my Excel code, so whenever I enter this data, I should get all these calculations done completely. That's possible. So EDA can be done in Excel, Tableau, Python, R, so many more languages, so many more platforms, ClickView, Ultrix. There are so many more tools. There are n number of tools, I should say, n number of tools for doing it. Programming languages only two. Tools are many. Programming languages are only Python and R. And yes, one more, who's the king of all, SQL. Now, so if the data is coming to a data frame or in an Excel sheet, I would of course use Python pandas to do Python pandas and Python numpy to do my EDA. And post the EDA, I would come to know post EDA and of course domain knowledge. Post EDA plus domain knowledge. Remember, your common sense and domain knowledge is never going to get replaced. That is always going to be intact. Be rest assured. What will get replaced is you as an individual, as a human, if you don't upgrade yourself. Why? Because see, your domain knowledge is going to remain with you, you agree. But if there is no taker for a domain knowledge, because the domain knowledge has already been captured into the AI system, then what is the use? Then what you can do, the system can do it by itself. So why do I need a human for it? Isn't it? So post EDA plus the domain knowledge which you have, you would decide you would choose M out of n features. This is one approach of doing it. This approach, of course, we have taken it lightly because of the fact that in most of the situations, the data that was given to us, we took all the features. Because the data that was given to us, data set which was selected by me for showing all the experimentations were having like 13, 14, 15, 20 features, maybe 25, 30 features. We never had exorbitant like 145 or 200 features ever. But yes, we can have it. And so how do you choose that? So that's what you're going to learn in feature extraction. Feature extraction is an algo which is yet to be learned. It is yet to be learned, but I would give you a brief about it, what feature extraction does. By the way, what we're going to do is we are going to learn PCA. Don't ask me full form now. PCA full form is, by the way, principal component analysis. It's an unsupervised ML algorithm, ML algo, and it is used for dimensionality reduction. It's used for dimensionality reduction. That means you're reducing the dimension. So what does dimension mean? Dimension means the number of columns. Dimension means number of columns. So you're reducing the number of columns. So principal component analysis is an unsupervised ML algo, and you're doing dimensionality reduction by using it or by going through this. Right. Now, the next part that comes up is, I repeat, the next part that comes up is, because we're doing feature extraction yet to be learned, PCA, what exactly we do here is that, let's say we have 145 present original features. So we use those 145 original features and actually create new 145 features. So what is the use? Patience. We create new 145 features where every new feature is a weighted mean of the old 145 features in such a way, in this way, where NF1 is going to have the highest contribution. Assume a contribution of, let's say, 50% of the old feature F1, and it is going to have 1 upon, there are total of 145 features, huh? Out of 145, 1 is taken out, so it will be 1 upon 144 equal contribution for every other feature. I will say, अरे रॉकी जी ऐसा करोगे तो फिर तो हार्डली कंट्रीब्यूशन हो रहा है F2 का, F3 का. बिल्कुल सही कहा आपने. वही तो मैं चाहता हूँ कि मेरा जो न्यू फीचर NF1 बने, it should have the highest contribution of, it should have the highest contribution. In fact, 1 upon नहीं होगा, it will be 50 upon, because बाकी 50% बाकी बचा है ना, 50 upon 140, 50 upon 144. So 50% has been gone over here. That is 0.5 has gone for this. Now the balance 0.5, that is 50%, I would like to divide it by 144 and give it to each of the other values. So I understand that the rest 144 features will get hardly 0.2, 0.3% contribution. That's what I want. Simple as that. This is what I want. So what happens is, I come to understand that the new feature NF1 created will have the highest contribution of F1. So in that case, so the next will be the same exactly. So NF1 is a weighted mean of the old 145 features with F1 having highest contribution. Okay. Now, similarly, you obviously you understand that suppose if I take at random and ask you that what do you think is going to be for F23, and I'm sure you're ready with an answer, you will say, "Arey, now to we know." 50% on 144 for F1. This will continue. This will continue till the time you reach to 50% contribution in between of the variable F23, and then once again you're going to be back to the original state where you are looking at a value of 50% of 144 divided by 24th value, and it continues thereafter. So obviously NF23 is having the highest contribution of 23rd original feature. Now, what do? Is we do a delta. So when you do a delta would actually correspond to making a change. So you could do a delta over your NF1. So if you do a delta over NF1, that means you vary NF1, then automatically you will see a change in the output. So you're measuring you're keeping all other parameters constant. Delta means making change. So delta NF1 means you make changes to NF1, keeping all other features, constant. उनमें कुछ changes नहीं होना चाहिए. You will measure the delta. In the output. हाँ सर, उससे क्या मिलेगा? उससे ये मिलेगा दोस्त कि जब आप डेल्टा मेजर करोगे आउटपुट में, तो आपको ये पता लग जाएगा कि what is the influence of NF1 with over the output. So this helps you to calculate, then find something called as variance. So you're finding the variance. That means if I change NF1, what is the change in output? So I'm able to get the variance, or rather, just to not to confuse, you can say covariance, because you're doing variance between the two terms. Covariance between NF1 comma output. ठीक है, fine sir, मिल गया, अच्छी बात है. Okay, supposedly you get this value. Suppose you get, let me put it this way. Let me put it here. Okay. So suppose you get the covariance of NF1. So you measured for all, and the first time it came was, let's say, 23%. Covariance of NF2 over the output, let's say you got 45%, and like this you got for all the values. Now, if you say that you want top two PCs, top two principal components, then you will pick up those two NFs which are having the highest covariance with respect to the output. So top two covariance supposedly comes out as this one, and let's say 26, and that happens to be 44.6%. So these are called as two principal components. So two principal component analysis actually found that these are the two new features you should use, NF2 and NF26, and you will say, "Arey sir, ये दो features important है, तो मतलब आप बोल रहे हो कि second and 26 feature is important." No, don't get me wrong. I'm not saying that the second feature and the 26 feature is important. No, I'm saying the new second feature, the new NF2 and the new F26 features are important. हाँ सर, एक ही बात हो गई ना, F2 और F26 नहीं हुई, क्योंकि जो F2 है वो केवल एक इंडिविजुअल फीचर है, और जो NF1 है उसमें हाईएस्ट कंट्रीब्यूशन F1 का है, मैं मानता हूं, लेकिन बाकी को भी कंट्रीब्यूशन तो भी है ना. So the disadvantage which we get in feature selection, where we blindly, after doing the EDA, drop the unwanted columns because we choose M out of N. So obviously if N is 145 and you selected 20, so 20 out of 145 has been selected. That means 125 columns have been dropped. 125 columns drop करने का मतलब there is a loss of information. There is a loss of data. You had the data, but you didn't capitalize on it because your model was going too heavy. It was taking too much of time to get trained. It was straining my resources. So I had to drop a few columns. Instead of dropping a few columns, could you take a weighted mean of all the columns and then choose which ones are most important? That was what PCS says. So if NF2 is selected and NF26 is selected, I understand this means that the column F2 is the most important, the column F26 is the most important, but that does not mean the column F1 and F3 are not considered. They are also considered because NF2 and NF26, both of them, or for that reason, any new feature is made up of all the columns. It is made up of all the columns. Remember this, it's made up of all the columns. Yes, the importance of the column in concern, so this is NFI, then FI column would definitely have the highest importance, not more than 50%, up to 50%. And the balance would have got distributed among all of these equally, right? So that's the whole principle. So that is a way you select the two principal components. Right, so Atmu's first question goes answered. Nitin, this is also for you. So your question feature selection gets answered here. Now, how to choose the most apt features? I hope this has got answered as above. Okay, right. So Atnu and Nitin, is this sufficing? At the moment, is this sufficing you?
Yeah, sir. Actually, we at least get to know this is a PCA, that is the principal component analysis, where we can do the dimension reduction technique, and based on that, there are some logic which I think there you will be covering future, right? I mean,
there is a separate notebook for it. There is a separate notebook for PCA completely.
Okay, sir. Okay.
Yeah.
Sir, one question here.
Sure.
We received the top two principal components as a 45 and 44.6. So that means these are the weighted means for that values for the column.
No. This is a covariance. That means any change in NF2, if I change NF2 by 100, I see that there's a 45% change in the output, either positively or negatively, either way, because this is not correlation, this is covariance. So, but there is a change in the output. That means out of many features, the feature NF2 is affecting the output the highest.
Okay.
You getting me? Is influencing the output the highest. See, what do you mean by the most important feature? Most important column का शून्य मतलब क्या होता है? It means that out of all the columns, which column has the highest influence on the output? That means if we change a little bit here and there, the output changes. So that is the one which will help us to actually, identify whether if I train my ML model on these two columns, NF2 and NF26, then obviously I'll be able to get a better response of prediction, because any change in them definitely causes a change in the output. So if my ML model gets trained on NF2 and NF26 instead of getting trained on the plain 145 features, then I will first of all have a simpler model because I got trained on only two columns. Second, I will have a quicker output because I have to test only on these two outputs or these two input features to get my new output.
Okay, sir. Then in that case, we should take those two values as they are like important features.
Yes.
So we should not ignore those things.
No, we have to take these two features, NF2 and NF26, and train our model on NF2 and NF26.
Okay.
Yeah.
Sir, I have one question actually. Sorry.
I can hear two voices. Please tell your name so that I can give turns.
Sai here.
Yes, Sai, please tell me.
Yeah. So how can we decide on the principal components?
That we will do when we do the principal component chapter. Don't worry about it.
Hello.
Yeah, sure. Yeah, please tell your name so that I know who I'm talking to.
Sir, one question I have. Sir, so yesterday actually you showed like that we have one. I mean, properties that we can do the regressor dot feature selection, where we can do the top 5 or 6 or top based on that contributor, we are actually categorize those column, right? So will it be will it be help or
yes,
or
yes,
the
it will
piece?
be useful here. It will be useful here. But again, that comes in the category of feature selection.
Yes, yes, yes.
It's a part of features, not feature extraction. So feature selection by EDA or by ML feature. No, it is basically what we're doing is that we are looking at the feature importance using the ML algorithm or by using ML feature importance.
Yes, feature importance. Yes.
So both the options are possible, whatever you feel comfortable. Although I don't prefer this much, to be very honest, because that's a very time consuming process. It's better to do EDA or to go to PCA. So
Yes. So, sir, one thing actually, what I came to my mind actually. So before, after doing the EDA, at least we can, when we are actually applying the ML, algo model, then we can at least have a look, right? What are the features is most important after doing my EDA? Let's say,
of course, EDA is compulsory. You cannot start you cannot start an ML machine learning practical real time run without EDA. Don't even dream that.
Yes.
You have to do it. Yes.
So just one question in this covariance NF2 output जो लिखा है, just can you scroll down on that? Yeah, okay, we can have it here. NF1 and 26, yeah, NF2. Yeah, NF2 and NF26. Okay. Now, actually, in this case also, when we are working on NF2, some portion of NF26 is also involved in that. Right?
Of course, yes. No, not NF2. In NF2, all the 145 participants are involved, but the contribution of F2 is the highest, and the contribution of others is one upon 144 of the rest.
50 by 144. So, but it will also have NF26 of 50 of 144 in that, right?
Yes, it will have.
That means it will be NF26 will get added into NF2 also a little bit.
But that is applicable to NF26 also, no? It will also have F2.
Right.
Yeah, so that's absolutely fine. Yeah. So that doesn't increases the importance of it, but per se, it's playing a role play where you are ensuring that every feature is having a contribution of every other feature. So you don't end up losing it.
भेल बनाने जैसा.
ठीक है, वो जैसे आपको ठीक लगे, याद रखने के लिए जैसे आपको ठीक लगे. Right. Okay. Fine. So I'll come to question of Srini and Usha Kiran now. Strategy for handling NaN or null values. So this I'm not going to use the functions, okay? That we have already done. The question now is of strategy. This can also be categorized as part of data cleaning. This is a part of data cleaning, to be very honest. Okay. Yeah. Now, the point that comes up here is, friends, is that when I'm looking at null or NaN values, to be very honest, you need to figure it out that where are these NaN or null values present. So the first question you need to ask yourself is, where are these null or NaN values present? So क्या मतलब होता है where का? वो तो columns में ही होंगे, बिल्कुल सही. So then your heart will answer you. I won't be able to answer. Your heart will answer that are they present in less important? So you have found the columns now above. So are they present in less important columns? You have already found which are the important columns above. So are they present in less important columns? Answer is if yes, drop the column. Don't even think further. Drop the column. Close the chapter. But अगर वो important columns में है तो तो strategy picture में आएगी. But if they are present in the important columns, then तो drop करने का सवाल ही नहीं उठता. ये बात तो सही है. But if they are present in the important columns, then you can't drop them. That's very natural. You have to impute them. So impute means replace karna. So when you say you want to impute them, obviously imputing itself will have its own strategy, right? That's correct. So what's going to be the impute strategy? The impute strategy is going to be as follows. So if you have numerical data, okay, if you have numerical data, I will not be taking so much of more time to discuss this, but if you have numerical data, then you should look at either a mean or a median. That is a very simple strategy. If you have outliers in your data and you believe that there could be outliers in your data, for example, the housing data set which had outliers, some houses which are very cheap, some houses which are superly expensive. If there are outliers in the data, go for median. If you feel that there aren't much outliers in the data, for example, you're talking of sales of t-shirts on Flipkart or sales of t-shirts or ladies tops on Myntra, you will not have outliers. You won't have, trust me, you won't have outliers, because the ladies tops or gents t-shirts on Myntra would range from maybe as low as maybe 199 rupees to maybe 1099 or maybe 2500. You won't have tops of 1 lakh, 5 lakh rupees on Myntra or on Flipkart. Neither will you have tops of 1 rupee and 2 rupees there. So you have a range of t-shirts and tops, so for men and women both, so there is going to be valid range. So you should in that case can go for mean. So no outliers, simple, mean. Outliers, go for median, simple answer. What if the data is categorical? Coming into it, if the data is categorical and you think it's appropriate, you can go for mod to replace it. Mod would be a good decision. If it's categorical data, go for mod. Mod means the highest frequency data, which is getting replacing the NaN values. This should be a strategy. But when should you use the import strategy is also important. Okay, so impute strategy may opening notice impute when, mark my words, impute when you have at least, you can discount it a bit here and there, you have at least 80% of the data. So impute when you have at least 80% of the data values. That means in that respective column where you plan to impute, you should have 80% values in place. ऐसा ना हो कि 50% values है, 50% values NaN पड़े हुए हैं और आप चल पड़े impute करने के लिए. भैया ऐसा नहीं करना है. 80% का आप 79 सोच सकते हैं, 78 सोच सकते हैं, 75 तक सोच सकते हैं, but you can't discount it way back to 50%. 50% था रॉकी जी, 50% नहीं था, impute कर दिया हमने. ऐसा थोड़ी होता है भैया, क्या कर रहे हो? जाओ डेटा सोर्स जहां से डेटा कलेक्ट किया उसके वापस इंटरवीन करो कि ये कॉलम इंपॉर्टेंट है, डेटा चाहिए हमको. राइट. नेक्स्ट इज द 14 ML algos. ये तो मेरे लिए भी टास्क हो जाएगा याद करना. चलो याद कर लेते हैं. लीनियर रिग्रेशन, देन lasso regression, then ridge, elastic net, ये तो रिग्रेशन के हो गए. फिर शुरू हुआ हमारा जर्नी विथ क्लासिफिकेशन. There's logistic regression for classification. So the first few are for regression. The rest which I'm talking about are all for classification. Naive bias and logistic regression and naive bias both can be used for making baseline models. Both can be used for making baseline models. So I would happily put a dollar symbol ahead of them and indicate by dollar that they both, and this is the answer to somebody else's question, कि कौन से algorithm से शुरू करना चाहिए. So they both are starting points for any classification or any classification problem. Again, the question that comes to proxy mind, whether I should logistic regression or naive bias, I would advise you to use both. as a starting point. So you have a baseline model, and uh, you can use logistic regression preferably when you have simple x versus y. But if you are having a data which is uh, too much of categorical in nature, then also you should logistic regression. But if it is too much of categorical in nature, then avoid using naive Bayes. So this is something which you should look into. Okay, I'll put it more in formal words so that it is more easy to understand. Use logistic regression when you are having few uh, x, that means few features, versus there is only one y variable. But comparatively, if you are having larger x, that means larger number of x, larger number of features versus one value of y, then I would suggest that you can go for naive Bayes. But I'm again repeating, as my learnings and experience, I would say my junior use both. दोनों मुझे करके बताओ. Simple. This is going to be my starting point. So they both are straight for starting points for any classification. Both, or the best of both, could be treated as a baseline. Not the worst of both. I said best of both could be treated as a baseline. मान लो लॉजिस्टिक ने आपको 80% दिया, इसने आपको 81 दिया, तो आप 80 नहीं लोगे baseline, 81 लोगे, because both are baseline models. So you will take 81 as a baseline model and compare it with other classification models which are little heavier. So who is heavier? सोचो आप कौन है heavier उससे? Decision tree उससे heavier है कि नहीं? हाँ, पर decision tree में दो आते हैं, बिल्कुल सही कहा आपने. Decision tree regressor भी आता है और classification भी आता है. The decision tree regressor, let me dump it in the regression. The same question, starting point, कौन होगा? Starting point is always in regression, always आंख बंद करके is linear regression, is nobody else. हाँ रॉकी जी, वो डिसीजन ट्री कलेक्शन बना दो, रैंडम फॉरेस्ट मिलेगा. देखो अब तो होशियार हो गए आप लोग, शाबाश. रैंडम फॉरेस्ट रिग्रेसर बनेगा, करेक्ट. Similarly, you are going to have a decision tree classifier and random forest classifier in the classification set as well. तो dollar का मतलब होता है that they become starting points, so that applies on the up dollar symbol also. So obviously I could put it over here immediately after this. The dollar is that it is the starting point, makes baseline model. So you make a baseline model out of it, and then you check with all other models that which model is probably doing better than him. That becomes the kind of a reference point for you to compare things. Okay, right. Then after decision tree classifier and random forest classifier, our friend has asked right now कि light gradient boosting model and XG boost, which means extreme gradient boosting. इसका lighter version है light GB. So model जो है वो use कर सकते हैं. Again, this fellow XGB has a regressor, and it has a classifier. So let me take this regressor and also dump it out over here, and let me convert this to a classifier. Yep. So a lighter version of it is, because we just had a friend of ours who said that, so let us put it over here. It's light GBM, because there are many lighter versions for many of the algorithms, so that's okay. Right. So how many algorithms I spoke about? I don't know, maybe I missed something. Please, miss तो किया होगा definitely मैंने. 1 2 3 4 5 6 7 8 9 10 11 12. ये तो आज बात हुई तो उसके लिए फिर इसको मैं गिन नहीं रहा हूँ. I forgot now. मुझे भी याद नहीं आ रहा. कल क्या पढ़ा था आपने? K means पढ़ा था ना? K-means classifier or SVM? Correct. Correct. तो SVM पढ़ा था, SVM में 3 kernels थे. There were 3 kernels in SVM. 3 kernels for classification. So SVM के 3 types हो जाते हैं in short. 3 kernel, 3 types. And K means आपने कल पढ़ा था, वो तो बिल्कुल fresh होगा. ठीक है. तो ये हो गए 14 algorithms आपके. इसमें चाहिए तो मैं इसको हाल फिलहाल कट कर देता हूँ. जैसे आपको डिस्टर्ब ना करे, ये 14 लिस्ट है क्योंकि सवाल आया था, तो इसको हम एज अ नोट डाल देते हैं यहाँ पर. Light GBM is it's same thing. It's little more than a decision tree, little less than an XG boost. बस बीच में खड़ा रहता है भाई साहब. It's a lighter version of XG boost. Lighter version of XG boost. इसका सवाल था श्रीनी और उषा किरण का अगला सवाल है, what is meant by underfitting and overfitting of data?
Sir, I mean, like, before we are going to the next question, one question here.
एक second, Srini, एक second. Let me cut this question and put it out over here. क्योंकि दोनों आपस में इंटररिलेटेड है. Please ask.
Okay, sir. Can you, I mean, like, go back to the... Okay, here in the logistic regression, I mean, like we mentioned the few X versus Y. So X here in the sense, I mean, like a column values.
Few, if you have few columns, few features versus one value Y which you wish to classify on, then you should go for logistic regression. Ideally, logistic regression was made to have one X versus one Y, like predicting, that is classifying sales of house based on the square foot area, classifying sales of house based on the locality. But then logistic regression got extended where it could handle few X. But if there are a little more larger number of X, like 10, 15, 20, then you should go for name based. Don't go for logistic regression.
Okay. Can you scroll little up as well?
Yes. More.
Yeah. Like in the null and NaN values. So if there are like less important columns, yes, we can drop it. I mean, like, so we have to be decided if it is a less important or like a high important.
No. So you have done that. No? You have done your EDA before, no? You have finished with your EDA and piece. They are all interconnected. No? Now just a storyboard. So you have done your EDA and your or your ML feature importance or your PCA. Something you have already done. So you know which columns are less important and more important. And in those less important columns, if you're having lots of NaN values, then you should drop the column.
Okay. I mean, like, what are the things, I mean, like, we need to be considered in process of EDS?
There is no fixed process in the way of EDA. EDA is you need to build a hypothesis and you need to work towards a hypothesis. So if your hypothesis says that the sales prices of the house in your locality is proportional to the square foot area, this is the hypothesis made by you, then you're going to do everything in the EDA, that is make graphs, make plots, use value counts, write simple lambda functions to check out the data, use describe, and do whatever is required in terms of the Python pandas functionality, whatever pandas provides you. So you use all of that to decide whether I should, is this my hypothesis going true or not? And if the hypothesis is going true, that means to predict sales, the square foot area is definitely very important. And of course, printing the correlation matrix by using the function CORR, or probably making a heat map. So that gives you an idea of what parameters are correlated to other parameters, as well what parameters are correlated to the output parameter. You get me that on Srini on this?
I mean, like, not 100%, sir. So, but I.
Why are you not able to recall? We have done so much of EDA. Why are you not able to recall that? Please recall. No, EDA तो हमने किया है काफी कुछ. आप तो प्रेजेंट थे लेक्चर में, ईडीए लेक्चर से प्रेजेंट थे ना, स्टार्ट में था, मैं जुड़ा ही आपके साथ ईडीए में. The point which I got connected to your batch was NumPy. After NumPy, the next session I jumped on to Pandas and the Pandas Seaborn EDA. If you recall, I don't know. Telecom churn data set हमने किया था, याद आ रहा है कुछ?
Yes, sir. Yeah, we did. How many members are willing to churn or not?
So we were not predicting, rather we were finding out why people want to churn off the network so out of so many columns on what they were dependent, and we did our EDA and analyzed that the churning was happening due to complaint calls which the customer was making to the service center, and because he had taken an international plan, so he's a premium customer and he's making so many complaint calls, he was not happy, so he decided to leave or churn out of the network. So you built a hypothesis of why people want to churn out of a network, and keeping that question in mind, you started doing all the functionalities over the notebook to get some answer. That is the way it is. Second way EDA we did was very mild EDA in the web scraping regex exercise, where we did a regex and web scraping of the MTA data, and we got the train details, and then we found out which trains travel the most, what trains are traveling 8 o'clock in the morning. So we started doing EDA with that. So for EDA there is no predefined set of steps. It totally depends upon the data and the hypothesis which you want to prove.
Okay, sir. Yeah. And in this 14 ML algorithms, I mean, like, how we can decide, I mean, like, whether we can use regression or we can use the classifications?
No. So it's not a question of deciding. It's again in what the problem is given to you. You know, the problem is given to you for prediction of continuous variable, then you're going to have regression. So that I think I will have to answer here, no? That question comes here, no? When to use what ML algo? यहाँ answer करूँगा उसको.
Okay, sir. Yeah. Okay.
इसके लिए ठीक है. तो ये क्वेश्चन आंसर हो गया कि नहीं हुआ? ये 1 2 आई थिंक आंसर तो हो गया ना. हाँ, ये हो गया आंसर. ठीक है. राइट. चलिए अब
Sir, Sukant,
yes, Sukant, you would like to add something. You would like to add और सवाल मत पूछना सुकांत, नहीं तो पूरे नहीं हो पाएंगे. हाँ.
Input strategy when the numerical data either we are replacing with mean or median. So median we are using when there is outliers, and mean otherwise we replace with.
Correct. बिल्कुल सर. Right. So yeah, the next question goes as when to use what ML supervised algorithms. See, we know broadly the algorithms are regression versus classification. Now, इन दोनों में से कोई एक यूज करना, इतनी बात तो पक्की है. So either, so the very first step is not deciding the algorithm actually. पहला तो algorithm कभी होता ही नहीं है पिक्चर में. algorithm बहुत बात की बात होती है. First of all, you need to do EDA, define your hypothesis. सॉरी, बाद में डिसाइड होगा. हाँ, रिग्रेशन क्लासिफिकेशन में बहुत बात की चीज होती है. कौन सा एमएल को यूज करना है वो तो एकदम बहुत बात की बात होगी. मान लो आपको आज संडे है, सब कुछ खुल चुका है, ऑलमोस्ट खुल चुका है, और आपका प्लान है कि आपको आज फैमिली के साथ बाहर डिनर पर जाना है. दिस इज योर प्लान फॉर टुडे, and you're not gone out for together with the entire family of 4 5 6 7 members out for a dinner from the last 6 7 8 9 months. You haven't gone. You ordered food at times from outside, but you haven't gone together, so you want to go. Okay, cool. Will you actually order food now? So now matlab 12:27 you're planning to go for dinner tonight at 9 p.m. Would you order food now? No sir, I won't. Exactly, you won't order. You will first shortlist the restaurant. First you will choose what food you want to eat. You want to eat veg, non-veg, Chinese, and then you will come down to the restaurant. Then you will pick up the menu, then you will order the food. So ordering the food is like, which algorithm of regression or classification should I choose? तो बहुत बात की बात हो गई वो. Correct. तो पहले आप EDA करते हो. Imagine you want to go for a restaurant with your family for dinner tonight. You will first do EDA, explore data analysis. Which restaurants are good in this current locality? You know it, ठीक है, but still you are going to explore. You talk to the family. इधर चले क्या? A में चले क्या? B में चले क्या? C में चले? नहीं आज क्या खाना है? सब लोग से पूछा, फिर सब लोगों ने बोला नहीं नहीं हमको तो आज वेज चाइनीज खाना है. सो वेज चाइनीज खाना है तो वो तो फिर C में अच्छा मिलता है, वो तो A और B में अच्छा नहीं मिलता. So what are you doing with your family? You are doing EDA. Next step. Then with that EDA you defined your hypothesis also. Because you did an EDA, you got to learn the data a little better. Then you defined a hypothesis. Okay. That let's say now, let me come out of the restaurant and let me look at some real-time data. Let's say that if I'm talking of data of flights takeoff and landing at an airport. Okay. Let's say at Bombay airport, we're talking about flights taking off and landing. And we are defining our hypothesis that the average waiting time of the airline in the sky, they just keep rotating up and goal ghumte rehte because they don't get chance to land on the runway because the runway is busy. So the average waiting time, I may not be right to the word, but the average waiting time in the air when they're circulating around the airport is, let's say, 22 minutes for every flight in Bombay at an average. Now, if it's 20 or 22 minutes at an average, especially during the peak hours, then obviously there is going to be wastage of the fuel at the airline end. But the airline knows that is if it's going to travel from Chennai to Bombay, चेन्नई से वो perfect time पर take off करेगा, but Bombay में वो perfect time पर land करेगा वो guarantee नहीं. And the landing time at Bombay airport already has taken that average waiting time into account. It is already taken because the flight journey time from Chennai to Bombay could be 1 hour 20 minutes, but it says 1 hour 40 minutes. Why 20 minutes क्यों add किया तुमने? वो इसके लिए add हो गया क्योंकि the average waiting time for landing is you get 20 minutes, post 20 minutes we're getting the signal to land. So that is being taken into regard. So can we say that the airline cost is proportional to the airline ticket cost per passenger on a route is proportional to the average waiting time at that airport before the plane lands? Sir, we can say, but you have to prove it, no? So you define a hypothesis for that. And once you define your hypothesis, you will actually again go and do some more EDA. Sir, why? So there is an EDA part 1 and EDA part 2, which you have actually been doing, but subconsciously you have not realized it. Because I have never come out saying that ये हमारा hypothesis होगा, ये अब हम वापस EDA कर रहे हैं. आप बोलोगे ठीक है रॉकी सर ना, वैल्यू काउंट्स निकाल रहे हो, डिस्क्राइब कर रहे हो, एक काउंट प्लॉट आपने बना दिया, बार ग्राफ बना दिया, स्कैटर प्लॉट बना दिया, बट जो मैं वो कर रहा था वो सब EDA था. वो जो आप देख रहे थे, आप मेरे साथ कर रहे थे, कभी बार ग्राफ बना दिया, कभी काउंट प्लॉट बना दिया, कभी कोरिलेशन मैट्रिक्स बना दिया, वो क्या है? So EDA 1 to get the knowledge of data, define your hypothesis, again do EDA 2. Okay, now after doing the EDA 2, you are very clear. At this point, you are clear. Now you are clear. Sorry. Now you are clear with your features, that is X, and the target variable. कि किसको मैं target लूँ? सर वो तो hypothesis समझ में आएगा नहीं. Hypothesis तो English words में होता है ना यार. Hypothesis in English words. but अभी जो आप कर रहे हो वो like वो segregation हो रहा है. What you're going to put in the feature set X and what you will drop and only pick up for the final target variable Y. अब decision हो रहा है भाई X और Y का हम code लिख रहे हैं, X में क्या आएगा, Y में क्या आएगा, इसका decision हो गया. Now we are clear on the features X and target variable Y. Now further think a bit about it. Is the variable Y a continuous variable? ये आपको सवाल अपने आप से पूछना है. Is the target variable Y? Is target Y continuous? Question mark. Is target Y continuous? Simple as that. So is target Y continuous? If the answer is this, then obviously you are trying to predict the next value given, and this becomes a regression problem. So if the answer is yes to this, if the answer is yes, then most of the times it's going to be a regression problem. Then it's a regression problem. Else it's classification. So it totally depends upon our hypothesis. So is target variable Y continuous or not? This is one way of deciding it. And second simpler way of deciding is that you check out your hypothesis once again. So regression, okay. Then fifth problem, fifth way. So I would use the word or. I'll put it as 4A or 4B. 4B. Right? 4B. So what is 4B going to tell me? 4B tells me that I'm not bothered about whether the variable is continuous or not, because even if it's continuous, I can make it discrete by, by binning it. So my interest is to classify my data. So if you're very sure you want to classify data, then the question is over. But why you're classifying data? Because your hypothesis needs it. You want to classify your data. For example, if I'm not talking about the price of the air ticket is proportional to the average air waiting time. If I'm not doing this proportionality relationship, then it's not a continuous variable. Then I could actually put it this way, that do flights more than 2 hours, do flights more than 2 hours offer higher discounts compared to flights less than 2 hours? So I'm very clear here that I've got two bins, less than 2 hours, more than 2 hours, and I'm looking at, does the flights less than 2 hours offer more discount, less discount to their passengers, because they're like short trips, and flights have more than 2 hours offer more discounts to their passengers. So my next way of analyzing would be is depends on your hypothesis. Simple as that. What is your hypothesis you want? Prove क्या करना है आपको? Check क्या करना है? What do you want to find? उसके मुताबिक it will depend whether it's regression or it's a classification. Tips to shortlist the algos to be tried. I would just say refer dollar in topic 14 ML algos supervised ML. Because I've given you the starting point there. I've given you the baseline models. So start with baseline models always. There is no other quicker way of doing it. कि सर मेरे को कोई जड़ी बूटी दे दो, मैं च्यवनप्राश खा लूंगा, मैं डेटा को देख के बता दूंगा कि ये वाला algo यूज करना है. ऐसा डेटा साइंटिस्ट अब तक पैदा नहीं हुआ दुनिया में, पैदा होगा भी नहीं. Right? Because all data have different ways of doing it. It's like a doctor. You really cannot expect two doctors to prescribe you the same medicine exactly and do the same diagnosis. So remember, the field of data science, AI and ML is exactly like the medical field. And whatever it is paying now, probably it will end up paying 2x or 3x maybe in the next 10, 15 years. The reason is very simple. As a doctor becomes more and more senior, his experience becomes more and more. And therefore, he's able to diagnose cases. And from his past experience of human body's behavior, he's able to diagnose cases more. Therefore, you have surgeons who are more experienced. They charge a bomb for an operation. They say, you can say the operations are being performed according to a protocol. Why charging so much? He's charging so much because a surgeon is charging so much, not because of the fact that he's doing an operation. He's charging you because, sir, he's having a lot of experience. No. He's charging you because if there is any critical condition that comes during the operation, he will be in a position of handling it. And if a surgeon who is less experienced may not be able to handle, causing death of the patient. So any critical condition comes, an experienced surgeon can handle. And the critical condition is unknown. It's absolutely unknown, unseen territory. Before the operation begins, nobody knows what's going to happen, right? So same thing in data science. Trust me, it is purely data science is exactly the same way, because you're dealing, when you train your model, you ultimately apply your model on absolutely unseen, unknown data. It's coming from the real world to you. Your model has to work well there, right? So I hope you're able to correlate between the two. So the medical profession of a doctor, of a surgeon, and a data scientist, AI, ML are both similar. They're both similar. Two data scientists, two ML engineers will never ever give you the same diagnostics. Never. Okay. Right. So, and therefore, if you feel that, then whom should I follow? I'm hearing Rocky Jagtiani also. He's also a senior person. I'm hearing another person also senior person. You have to hear all. You have to hear all, but you have to do what you feel is the best at that point of time. There, where your common sense and sixth sense comes in the picture, which God has gifted every individual. Okay, and then your experience will teach you. इस पर मुझे क्या करना चाहिए, क्या नहीं करना चाहिए. But there is no jari buti. कि डेटा पर ये अप्लाई करना है, ऐसा कुछ नहीं होता. Right, moving on to the next question. After this question we will take a questioning a break. Sai Venkatesh asked this question: when should we stop trying different models over our data? Correct. See now, Sai, it is like this, that you know, the time you decide your hypothesis, ask at that time itself, ask the customer what accuracy he is expecting, or what accuracy is expected. तो सर कस्टमर कैसे बोलेगा what accuracy is expected? से कस्टमर आपको accuracy तो नहीं बोल पाएगा, 90% चाहिए, 95% चाहिए, इतना कस्टमर को जानकारी होती तो फिर वो आपको बुलाता ही नहीं, वो बोलता मैं खुद ही कर लूंगा. Customer will not be able to tell you what accuracy he is expecting in percentages, but he will be able to tell you it in business terms, that listen, if 100 people come to my app, then at least I should have 70 people correctly recommended. मतलब क्या कहा उसने आपको? 70 on 100, 70% खत्म. उससे वापस पूछने की जरूरत नहीं है आपको, सर आपको accuracy क्या चाहिए? That means 70% is a baseline model in the mind of the payer, one who is going to pay you, one is going to budget, one is going to finance your project. उसका baseline दिमाग में बात बैठ गई, 70% तो मुझे minimum चाहिए. अब वो 70% उसका खुद का सोचना है, या 70% उसका किसी और आपको कंपैरिजन करके हो रहा है, वो 70% पर कैसे आया is not our cup of tea. It is not our cup of tea. I repeat my words, because that person who is investing money into the project has his own background, he has his own experiences, he has his own learnings. If he's investing money without any learnings, then he's a fool. He may end up losing money also. But usually if he's a smart investor and a smart businessman, then he knows where he's putting in the money. And therefore, it's like very simple case, when you buy a stock, you are doing some analysis yourself, right? So the better the analysis you do, plus the sixth sense, plus the luck. Tell me one analyst in the world who says that I have always made profit. Impossible. Not possible. So if you are expecting that you're buying some stocks, you're expecting some profits to happen, then you are doing analysis plus sixth sense plus luck. All the factors have to be in picture, right? So the time you decide the null hypothesis, ask the customer what accuracy is expected. Create a baseline model. That means you use the above models. Create a baseline model and showcase your baseline model to the client. Because remember one thing, client will always be in this situation. Client can describe you what he wants, when he sees what he wants. सर क्या लिखा है आपने? आप एक मोबाइल फोन खरीदना चाहते हो, बिना दुकान जाए, बिना एक भी मोबाइल फोन देखे खरीद के बताओ मुझे मोबाइल फोन, नहीं खरीद पाओ. आपने कहा मुझे आईफोन 12 मिनी खरीदना है, तो आपके दिमाग में तो देखा होगा ना आपने वो फोन को? हाँ सर देखा है. बिना देखे मैंने कहा, देखना नहीं है आपको. एक नई इनोवेटिव चीज है, टेस्ला की गाड़ी खरीदनी है आपको, जो इंडिया में बनने वाली है. टेस्ला की गाड़ी खरीदनी है आपको, जो इंडिया में बनने वाली है, बैंगलोर में बनने वाली है. उसका इनिशियल बेस प्राइस कॉस्ट होगा $35,000. मल्टीप्लाई इंटू रुपीज जितना होगा वो, दैट इज द कॉस्ट ऑफ द कार. वो आपको खरीदनी है. अगर आपको वैसे कोई गाड़ी खरीदनी है जो टेस्ला बनाने वाली है, प्योर इलेक्ट्रिक व्हीकल, very safe, वगैरह वगैरह वगैरह, having some brilliant out of the world safety features which beyond imagination, मतलब गाड़ियों में देखा नहीं है वैसा फीचर. तो अगर आपको गाड़ी खरीदनी है, बिना देखे आप कैसे खरीदोगे? हाँ सर देखना तो पड़ेगा ना. एग्जैक्ट देखना पड़ेगा. So if I ask you now to describe the car, you have not seen a single Tesla car, you saying ऐसा गाड़ी मेरे को चाहिए, तो क्या करोगे आप? सर I'll make a drawing. Why you make a drawing? Because what I want, what the customer wants, he can only tell you when he sees what he wants. जब तक वो देखता नहीं है ना कुछ सैंपल, उसको समझ में नहीं आता उसको भी क्या चाहिए. His picture becomes more clearer when he sees a picture or something vague. This is the vague model which you're given him. Now the customer will start tweaking. ये ऐसा इतना एक्यूरेसी खराब नहीं चाहिए मेरे को थोड़ा सा बेटर चाहिए. पहला क्या कहा था उसने 70 और 100. अब वो क्या कह रहा है, जब आप उसको 78% एक्यूरेसी लेके गए बेस मॉडल के, वो बोल रहा नहीं आ रही, इतना सारा मिसक्लासिफिकेशन नहीं चलेगा, इतना रॉन्ग प्रेडिक्शन नहीं चलेगा. ही विल स्टार्ट ट्विकिंग हिज वर्क. सो एंड वो होता है. दिस इज नॉर्मल थिंग. You can expect it now. नहीं expected तो something odd is happening. So customer would tweak his accuracy, and now he will be very clear. और हाँ accuracy का मतलब क्या था? What I meant to say. So customer definitely would do this. Okay, would tweak. He's not going to tweak his expectation. Expectation change नहीं होगा उसका. He would tweak his accuracy. Now this becomes new baseline accuracy which you have to achieve. Simple. So now you always, that is the way I've taught you also. I've taught you from least to more complex models, simple to complex. Notice my notebooks, they have gone in absolute correct sequence. So always start from simple and go towards complex models. So how much should I go? Patience. Always start from simple and go towards complex model, stopping immediately. Don't even think, don't even blink your eyes. Stopping immediately moment you cross the, you got it right, the new baseline accuracy. Just instant पर आपने baseline accuracy cross किया, उसी वक्त आप रुक जाओ. सर लेकिन ये वेरीफाई कैसे होगा? वेरीफाई करने का तरीका आपको पता है ना. वी विल डू क्रॉस वैलिडेशन. वो ट्रेन टेस्ट स्प्लिट करके नहीं करने वाले. वी आर गोइंग टू क्रॉस वैलिडेशन. It has to be tested on cross validation. So always start from simple and go towards complex models, stopping immediately moment you cross the new baseline model. Yes, now it is optional. You may, that's the reason I'm writing, you may optimize, check only via cross validation. No train test split 80-20. उसके भरोसे मत बोलना मैं baseline model क्रॉस कर चुका हूँ. क्रॉस वैलिडेशन के बाद जो आंसर है वो सत्य है, बाकी जो आंसर जो आपको आया वो झूठ है. सिंपल. Point number B, pointers to analyze a problem statement. So partly is that what I have already answered a number of times. So given any problem statement, you need to do your EDA1, EDA2. So when to use what ML supervised algo, this is what is exactly the answer for this question is. Any problem statement which you have, EDA1, define a hypothesis, EDA2. That's it, stop. This is your problem statement analyzed. Now you know what has to be done. Now you do depend on that is what is answered in the other questions. Type of data, type of model. Unfortunately, there is no concrete answer to this. So I'll not use the word wrong question, but there is models do fit on the data. But looking at the data, you cannot say what model I'm going to use. You have to do your EDA. So this is actually already answered in the point where we did regression versus. Yeah, so this is a question. So when to use what ML supervised algorithm, and this answer is the same. So looking at the data, there is not an answer. The answer is that what type of model means regression or classification. सीधी सी बात है. Because supervised आपने पढ़ा है. जब unsupervised पढ़ लोगे तो obviously unsupervised clustering भी picture में आ जाएगा, a priori भी आ जाएगा. ठीक है. So type of data, type of model. Answer is refer when to use what type of model above. That's the answer for this respective question. Okay, right? Right. So Atnu, you said I have a question. Yes, Atnu, over to you. Yes, Atnu. Oh. Atnu. Okay, okay. Unmute. Yes, yes. ठीक है. कर दिया.
Yeah, hi sir. Actually, there is an issue, so that is the reason my, I mean, this is got as actually unmute. So, sir, my question was that I know that for the, I mean, linear regression, right? To, I mean, this define this null hypothesis and how to get this, find it out, this the null hypothesis and all these things that we do by achieving the OLS model. But but in logistic regression, so how to actually we came to know for, I mean, that null hypothesis, is it, I mean, applicable, or we can reject this null hypothesis, or we can accept the null hypothesis?
Of course not. See, if you are you have to make a hypothesis according to the model which you plan to use, no? So if your hypothesis is this way, that more than 50%, read my question very clearly. More than 50%. Suppose your null hypothesis is like this. More than 50% of flights give at least 20% discounts. Now, what type of problem is this according to you, Atnu? Classification or regression?
More than 50% of flight give at least 20% discounts.
This is my null hypothesis. After doing my EDA on flight data.
Okay, so is it kind of a classification?
खत्म हो गई बात. So you know the answer. Confusion क्यों है दिमाग में फिर? आपको आंसर सब पता है.
Okay.
Simple. मैंने तो कुछ हेल्प ही नहीं किया आपको, आपने खुद ही आंसर किया. That's what you. इसके लिए मैंने कहा आपको, जब आप क्वेश्चन को एक बार, दो बार, तीन बार पढ़ोगे तो अपने आप आपको क्लिक होना शुरू होगा कि क्या है, राइट? ठीक है? या
ठीक है सर.
या Kiran, you're absolutely correct. Everyone, please read what Kiran has mentioned on the chat. It's a very valid point. Sorry. Okay.
Sir, one question.
Yes, Shri, yes.
Sir, I mean, like Atnu has like mentioned it's a classification because it's not a continuous data. So?
No. See, when I say more than 50% flights, so obviously I will classify the flights which are giving discounts as more than 50, as more than 20% and less than 20%. So I get two bins, so I get two categories to classify. Will you get me?
Yes, I understood.
Right? Okay. So I was just about to mention that we will be taking a 10 minutes break now, right? So let's get freshed up and come back. Right? So I hope you're enjoying it. So 101, we meet back. Yes. So, friends, I hope most of us will be back to our terminals. Could you just punch me a yes or something like this so that I come to know you're back to your terminals? Great. Okay. Yeah. So, Kavita, would you please come on audio first? Yes.
Yeah, yes, sir.
Yeah. Kavita, you wanted to share some thoughts. That's what you told in the break time.
Yeah, I wanted to share my screen, so because it's just
Okay.
diagram representation. So I thought,
Okay, okay. So many there are many such diagrams which help you to easily correlate of.
right, it's
Uh,
just my understanding because I've referred all your notebooks and I've made it into one page. So I just thought if my understanding is right, so that's the
just
thing.
a second. Just a second. Now, how do I? I have to just figure out. What do I have to do? I have to make you the host, right?
Yeah, it's, yeah.
Yes.
Yeah,
Please check now.
I've just done that. Mhm. Yes, continue. Okay. Yeah, is it visible?
Yeah, it's becoming visible now. Yeah.
Yeah.
Hmm. Okay.
I'm not sure how will it look in other system. If it's fine, it's visible, or I have to increase the size.
No, no, no. You have to reduce the size so that because the diagram is very broad, no?
Yeah,
So
but I would be going through the diagram as I move. So I'm just starting with ML. If I just put my
okay.
cursor, yeah. So
Hmm.
this is machine learning model, and once we have two types in this, which says one is supervised, and the
Hmm.
other goes into unsupervised. So
Correct.
unsupervised is where only we know X, and we don't know Y. Yeah.
Perfect.
And when we say supervised, it is when we have both X and Y is given to us over here. That's what is my understanding. Yeah.
Correct.
Further, the objective is of supervised model is to no, this is not for here. This is for classification. Yeah. So objective of when we come into this supervised model, now we have two types: regression
Hmm.
and classification.
Hmm.
Yeah, the objective of classification is we check accuracy, precision, F1. That is how we come to know if the model is good or no, the
Perfect.
objective. And the
Perfect.
objective of this is, I don't know where I've written, but I've written somewhere. But basically, the objective is we have to know the RMSE and all those errors.
Objective is to predict the value with the least RMSE.
Yes, yes. Yeah, predict the value with the least RMSE.
Hmm. Hmm.
And here in regression, we always look at best fitting line. And when we say for classification, best separating line.
Perfect.
Best separating line. So this will give the summarization of the differences between regression and the classification. And
Correct.
how I understand whenever we have a problem, how do we classify? For me, whenever we look at the Y has an output, when we want to know yes or no, true or false, I directly take my problem statement to be considered under classification hypothesis, and I take classification. I choose classification. But whenever I want to know how much will it increase, how much will it decrease, what I consider that to be a regression model. So
Perfect.
when people were saying, what kind of a model to choose, that was my understanding of
And it
choosing.
is absolutely correct. Absolutely. So when you say how much is going to increase or how much is going to decrease, in other words, it means continuous.
Yeah, so definitely I just go, yeah, in simple language, I just put in that,
Correct.
So
Correct.
again, when we come into regression, we have linear regression and we have non-linear regression. When
Mm-hmm.
we have regression linear, it is also called as OLS model, that is ordinary least square model.
Correct.
Yeah. And when we come under non-linear regression, we have these following types. Single variable, multi-variable, and for non-linear regression, we have polynomial linear regression.
Perfect. Perfect.
Okay. So I'll just come below these. See, what I'm trying to say, these are the common step you need to perform whenever we take any model. This is applicable for single variable, multivariable, or any kind of a. These are the common step. So we upload the data set, we put it into, we read the CSV file using Panda DF, and then we print the head to see how is our data looking. Perform basic EDA to understand size, info, mean, mode. That is a basic we do. And then do data preparation. That is what we do, cleaning of the data. So wherever the numeric object, convert that into string, all that integer pattern, and any other thing, whatever you have to clean the data, missing, select, mean, mode, whatever you want to do it. And then we perform feature engineering or scaling. Now, what happens is whenever we assign all feature engineering, I think would come later. I think it will be like assign all inputs feature to variable list that could be X, and we also assign output that is the target for our variable. So this could be Y. Okay, and from sixth point, when I say ki, all the input feature, we also segregate into category and numerical at this step. When we segregate into on the point 8 for the numerical data, we do scaling to normalize to when we have numbers ranging from 100 to lakhs, and so that time we use those log and we scale them. And for categorical data, we use one hot coding. And so categorical data could be text, image, video, whatsoever. We use one hot coding. But I think image and videos would come into non-supervised. Yeah, I'm
No,
not
no, no,
sure.
no, no. Image and video, we are not dealing only with that data, but then image and video have different feature engineering techniques. We don't use one-hot encoding
Huh.
because
Okay.
image and video, in which invariably are numerical data, because an image is stored as a numpy array.
Right.
Same applies for audio as well as video.
Okay. Okay. Yeah. So then we, after doing all these basic arranging of understanding of the data, we segregate data X and Y into train and test form. We select the model. So model selection, we make the object of the model and we fit the model. So till 12, it's the common steps what we have to follow the moment we take any model to work. So when we talk about linear regression, we have single variable linear regression and multi-variable. And then these are the other forms: random, decision tree, random forest, and XGBoost. And I have to update because I haven't done the further learning. So has
You have done an awesome job. जो काम आपने किया है आपको देखो, how many people will request you on the Google Classroom to share this file. So
right.
once it is fully completed, that time you share.
Okay, yeah, I'll do that. Once you do that, so when you come to single variable, continuing from this point, 12 point, when we say single variable linear regression, here we get one coefficient as we have only single variable. So there's nothing much to do here because it's one X and one Y. And then we predict the model on test data, that is 20%. We compare the actual result with the predicted to see how effectiveness is of our model.
Correct.
And then we evaluate the algorithm by using the performance metric, that is the mean square, absolute, RMSE. Here I've also given a comment that RMSE should be less than 10% of the mean. If not less, reject the model, else accept. So to bring about uniformity, now here I was having a confusion whether should we really do 80-20 or directly then go into cross-validation approach. Instead of segregation, we can directly, is it good to use cross validation? So that question I've already given it to you while we were having initially.
Initially, I would advise that when you're learning phase, it's 80-20, but when it comes to practical phase, it's only C.
Okay.
Learning phase 80-20, yes, everybody has to go, but when it is coming to the practical real-time phase, it is only CV. You cannot report to your client an 80-20 wala answer. You have to report to him cross-validation wala answer.
Okay. So we can directly apply cross-validation only. We don't have to do this step.
Yeah, exactly. Okay. So while learning, see, you're on the learning phase right now. So while learning 80-20 will be using, but when you're going to the industry, it's cross-validation, CV.
Okay, all right. Okay. So again, in multilinear from point 12, we follow this. We apply function to find coefficient among all the this one. So here was a point of Kiran that if we have to see, which factors are selecting the important features, we can go coefficient and we can clearly see which is affecting and select those. So we apply the function of coefficient. Here we get more than coefficient as it is multi. And then again, we predict the model on 20% and then compare actual with predicted to see the effectiveness, evaluate the algorithm by seeing all this RMSE and mean value and all that. If the results are not satisfied, then perform regularization. Here, then here we adopt the step. Then we see there's a lot of features and we really don't know which is affecting whom. Then we want to penalize two or more highly correlated function features. We apply multilinear. So here in multilinear, what we do is we select the model XY, apply cross validation. I think I've repeated. Here it comes from here. We have to apply this technique, ridge, lasso, or elastic net. So the important, I've just given the explanation how it works, when to use what. So that's how we do, and then we check the RMSE and fine. So I haven't done much for again decision tree random forest, because as your book went, we again went to logistic. So in logistic, I have my question over here. So in classification, when we say logistic regression, binary, that is when Y has only S and no has an outcome. We use logistic, and which you also said now when you have only less features. And everything else will come under multi-classification, like down this all naive, decision tree, random forest.
Yes, yes, yes.
All will come under multi-classification.
Yes, yes, absolutely.
And logistic would be the only one which comes into binary.
No, you can use all of them. Decision tree, classifier, random forest. When you say multi-classification, multi can be two, no? So
More
all
than
of them can, yeah. No, multi can be also two, no? It can be two. So of course, decision tree classifier, random forest classifier can be used for binary classification also.
Okay, all right.
Although it's going to be overkilling, so you'll probably be using logistic regression if you know it's a binary classification problem.
Okay, okay, okay.
That way. That's the reason I have marked both of them as baseline models. So if it's binary classification, you're going to go for logistic as well as for naive Bayes. But if it's a multi-classification, then you will not go for logistic. You'll only go for naive Bayes as a baseline model.
And then pick up random or whatever you want to pick up.
Yeah, then post that you can pick up at random decision tree उठाओ, random forest उठाओ, XG boost उठाओ, कोई भी एक उठाकर check कर लो कि are they performing better than the model, but don't pick up at random. You should go in sequence, as I have mentioned. So, which is the model in multi-classification? It is little more complex than naive Bayes. It's decision tree. Which is more complex than decision tree, random forest. Which is more complex than random forest, XG boost.
Okay.
That way. In fact, between them, I forgot to mention k-means.
That was taken yesterday, right? KNN.
Exactly.
Yeah.
That is not k-means, KNN, but k-means clustering, no. KNN, that is k nearest neighbors.
Yeah.
So k nearest neighbors, in fact, is simpler than the random forest. So after decision tree classifier, you will probably be trying with KNN, and then you will be probably trying with random forest, and then you will be trying with XGBoost.
Okay.
And before XGBoost, if you wish, you can, rather after trying XGBoost, if you think that you are getting a good improvement in the accuracy, but it's taking too much of a time, then you can discount on XGBoost by going in for light GVM, which Prasun just raised in the morning.
Okay. Yeah. Okay. I think that's the only piece of thing I wanted to share with you.
Yeah, but this is awesome. You see how many chats you have got. See.
Right. See, my idea is at the end of the day, I should have ML and everything in one place. At least gives me the synopsis how to follow. So that's what I said. Theoretically, we can do. When you have to code, things go here and why, and we stuck. At least I stuck.
Right. So, but ideally, this should be made by everyone. So everyone should put in an effort to make it. The moment you give it on the Google Classroom group, which they're all requesting for, then then the laziness will prop up and then say nobody will do that. So ideally, everyone should do that by. You may not use it. You may not use Excel or Word for people, because you may be an expert in Excel to do all this stuff. काफी time लगा होगा आपको सब करने में.
काफी. But then I kept doing. I gained confidence in understanding. And which में आप question पूछते थे in classes, I was able to answer because I just had a revision. So every day I used to pick up one book and put down this points over here, so and have an understanding.
Good, very nice. And one more thing which everyone can do exactly that, they can actually maintain a book, and like all these points can be maintained in a book, or maybe in a kind of a big kind of a drawing sheet, or maybe you can choose a Word document and try to put all that stuff there. So kind of thing people can do it.
Right.
So when you complete this, then I would request you to please share a Google Classroom with your colleague friends. And if you want to share it right away, and then they should continue with the filling up, that is also okay. So as you wish, it's your decision.
Yes, I'm okay. If the team wants, I would definitely share.
Yeah, so team is already requested you. They have somebody told you even boss of the team. ऐसा कुछ बोला है लोगों ने. You are the boss of our team. ऐसा करके
Thank
बोला.
you so much.
Right.
So how do I get back to you? Give you the screen share. How do I stop that? I just say end.
You have to say stop screen sharing. Stop share करके एक button आएगा आपको red color का.
Okay, I've done. Yeah, thank you so much.
Fantastic. Yeah. You will have to make me host.
And how that's done?
Yes. So go to the panelist section.
Participants?
No, panelist.
Panel.
There are two under participants. There are two participants. Go to the participant section. There are two attendees and panelists.
No, under participants, I only have invite button. Okay.
Invite button? No, there should be. Okay, let me check.
Make a host. Yeah, I have just made you host. Yep, done.
Super. Thank you.
Yeah, thank you.
Okay, so it seems, Kavita, everybody is saying that they want your contribution, your self-study work, and they will keep on updating it there on. So then that's absolutely fine. It's good. इनका habit भी पड़ जाएगा update करने का. Right. So now I'm going to Arvind's question, but Arvind's question is actually already answered partly is almost fully answered through Kavita's presentation. What kind of error to look for? So when I'm looking at what kind of error to look for, if it's a regression problem, then I would look for prediction with least RMSE value. To be very honest, you will not go for using mean absolute error or the mean squared error. The purpose of finding MSE is to actually calculate for RMSE. But at times, you will see that the problem is not, so easy to comprehend. So, but then again, you will go in for RMSE only. Very rare of a situation you're going to go for mean absolute error. Obviously, now I really cannot tell you in what situation you're going to go for mean absolute error, because there is no concrete, well-defined points के A और B refer कर लो और आपका ME आपको use करना उसमें RMSE use नहीं करना. So I will tell you to stick to with RMSE right now. And if it's a classification problem, then you're going to look at accuracy. But many times accuracy is on the lower side. So, or maybe two or more models are giving you the same accuracy. Then how do you decide? So that situation should look at the F1 score. So there are three parameters: precision, recall, F1 score. So look at for F1 score. So the model which is having a higher F1 score definitely would give you a better classification accuracy. Means would give you less misclassification if your F1 score is on the higher side. Post that, you will also look at, at times when these parameters are a little tricky to look for, then you could look at area under the curve, AUC. And this is a part of the regional operating characteristics, ROC, AUC. So for classification, you have so many things actually to look into, but the regression is only that you should predict with the least value of RMSE. One which gives you the least value of mean squared error is the best. Simple. Or mean absolute error, or mean squared error. So first preference is RMSE, second MEE, third MSE, because MSE is nothing but meant to derive this. So if I can delete this also, that should be good enough. How to simulate random state to get better results? No, we don't do that. So there's no need of doing that actually. See, we are actually working with the random state to get the train and test data. The whole ball game was that we changed the random state to get the train and test data separately, so that we are capitalizing on that train and test to understand where we are getting the best accuracy. But that is not the best accuracy actually. So the answer is uh, above step not needed. Use CV. Cross validation, simple. So your random state is out of the picture. Best train test size is 80-20. It's not best from point of view of be giving you the best accuracy. No, it's best from the point of view because all things in software development happens for 80-20 rule. So the best train size is 80-20 because see, ultimately we need to understand that data science is a subset of the software engineering industry, at least from a coding perspective. So anything which you design in software systems or in any allocation, even in HR also, or in admin or resource allocations, it's all 80-20 rule. So best train test is 80-20 because 80-20 principle is most used and tested. In case if you do not know 80-20 rule, तो बात दूसरी हो गई. But 80-20 rule or principle is the most used and most tested in all industries, in all sectors, in all industries for a very long time. So that is because of the older beliefs that this ratio is being taken. You're correct, Sukant. It's called a Pareto ratio. That's right. But then, not in technical terms, 80-20 principle. In case if you're unaware about, I would humbly request you to do a little googling to get this knowledge. 80-20 principle is very heavily used in resource allocation or in software industry. Please do read about it. उसका कोई लेना देना नहीं है data science से, but just do read about it. It will be nice. Okay. Right. So, Arvind, I'd like to call upon you. So, is your questions getting like to a certain extent answered, or is it that you're still confused and like to add on something more?
No,
Please,
it is
over to
answered.
you. Okay.
The answer. Thank you, sir.
Yeah. Kavita has made models, optimized it. Now, how to apply the model to new unseen data is very simple. So what we do is that once our model is made, make a pickle file of the model. Pickle file is basically an executable file. So you make a pickle file of the model and you host the pickle. The syllabus of DataFolkz, I don't see have a chapter or a session for deploying the ML models, but I will ensure that I convince them that there should be one add-on session for deploying, because if we can't deploy, then what's the big deal? Who will you showcase your work? So it's very important for people to be able to showcase their work, right? So host the pickle on Streamlit or Flask, okay, and test it on unseen real-time data. Tested on unseen real-time data. Okay, so making a pickle and hosting it on Streamlit or Flask is one of the easiest way to actually host your data. So that way your customer and your client and yourself, your team can actually test the model over a period of time. So model बन चुका है, model को change नहीं कर रहे, unseen data पर model को test किया जा रहा है continuously. That's the way you work on unseen data. Problem is understood. Python coding confused what to do. Kavita, I cannot comment on it. So I am to ready. I have just taken the session so many times for deployment. So you'll have to put a mail across to the backend team that we would require to have sessions on the deployment of ML models, at least 1 or 2 sessions, so that, right. So problem understood, Python coding confused, what to do. It's simple. See, this is the phase where everyone has to go through in life, and this is called as logic building phase. It's like when you learn driving. Now, I hope all of us will agree. All of us would have learned driving for the first time through a driving school. आपके घर पर गाड़ी है, आपके ब्रदर, सिस्टर, डैड सिखा सकते हैं आपको, लेकिन उन्होंने आपको नहीं सिखाया होगा. वो कहेगा नहीं, पहले आप जाकर ड्राइविंग स्कूल में जरा सीख के लाइसेंस लेके आओ, फिर मैं आपको अपनी गाड़ी पर सिखाऊंगा. अपनी गाड़ी पर आप बाद में सीखते हो, पहले अपनी गाड़ी पर डे 1 से अपनी गाड़ी पर नहीं सीखते. बाइक और होगी, बाइक इज अ डिफरेंट इशू, बट नॉट द कार. So you would first learn from a driving school, but tell me one student on earth, in India at least, who says that he has learned driving from a driving school and today he is confident to drive a Ola, Uber, or a private car or his own car, and he can drive fluently on the Bombay roads or on Delhi roads or on Bangalore traffic. एक बंदा नहीं मिलेगा आपको. वो कहेगा नहीं, ड्राइविंग तो मैं सीख के आया हूँ, ड्राइविंग लाइसेंस तो है मेरे पास, लेकिन कॉन्फिडेंट नहीं है. So he will have to then actually get onto a car and be very cautious while driving at least for 1, 2 or 3 months, and then he will get confidence. So you all are in that driving school phase now. You're learning driving, but you'll not feel confidence because जब तक आप सिस्टम से बाहर नहीं, जब तक आप ड्राइविंग स्कूल से सर्टिफिकेट लेकर बाहर नहीं निकलोगे, लाइसेंस लेकर, और खुद जब तक गाड़ी चलाओगे नहीं, तब तक कुछ नहीं होने वाला. तो सर फिर क्या करें? So इस फेज को करने के लिए you need logic building, and the best way to do logic building is to solve simple problems on hackerrank.com. So go to hackerrank.com and start solving simple Python problems. Start solving simple Python problems. Right? I do take workshops for all India students on HackerRank because I'm an official member to HackerRank. So, but then the problem is that those are for students actually. And you guys, none of you are students, right? You're all about 21. So maybe if I post on LinkedIn and if you come across, because some of you are not connected with me on LinkedIn, or maybe you don't follow me, or maybe you're not so regular on LinkedIn. Maybe that is a possibility. You're not so regular. You're just coming once a week or once, twice a week like this. So whenever I create a next posting, keep a track about it. And if there is a kind of, maybe it comes in the next 3, 4, 5 months. I don't know when it is going to come because my company decides and I have to just do it. But the point is that whenever it is, if it's convenient to you, try and attend, so that you come to get that habituatedness of how you think logically while solving a Python problem. This is not Python for data science. This is pure Python for logic building. So once you go to HackerRank, you'll understand what I'm trying to say. HackerRank has little tricky problems. They're brainstorming problems, and you have to solve simple. So when you look at the solution, you'll say, "Oh my God!" With their simple for loops, if else to be used, but how appropriately they are being used to solve a real-time simple problem is that you will realize here. Okay, so 80-20 or CV, it's only CV, cross-validation. Next. Okay, so Sukant, to see both of these terms, no, bias and variance are kind of interrelated. So if I say that my model is having high bias, I have shared a video also in one of the notebooks, so you can please look at that video once. If you have high bias and low variance, then we say that variance is low. So this model usually will be underfitting. It's an underfit model. I'll show you a diagram of underfit model right now. Just give me 2 minutes. Let me finish the writing work. Other hand, if your bias is low, we have to find a balance between both. That is a different issue. But if the bias is low and if the variance is high, then you are looking at a overfit model. You're looking at the overfit model. Now, so what is meant by underfitting and overfitting? Okay, I will just request you to watch this diagram here. So if I look at my model over here, this is an underfitted model because the variance is extremely very low. Bias is high, but variance is low. Now, if you ask me definition कि what is bias and what is variance, तो मैं आपको request करूँगा कि please आप वो video देख लो एक बार, okay? Because simply talking about the mathematical definition or one-word definition of bias will not help you, Sukant. So if I look at here, in this model, which is very simplistic model, it's nothing, it's just straight line which is going. Where are the points? What is the shape of this data? Where is the line going? अपनी दुनिया में चल रहा है यार वो. This is called underfit model. This line, that is an equation y equal to mx plus b, is not a good description of the data point which you have. And because it is not a good description of the data point which you have, it invariably becomes an underfit model. On the other hand, this model over here is overfit because it has a very high variance. It keeps on varying. Notice, it is dancing along the points. So if your model is dancing along the point, this model probably could have a very complex polynomial equation. This is a very clear cut of nonlinear polynomial regression equation, and a very complex equation will get produced by this. But then, because it's such a complex model, it is overfitting the data. Tomorrow, if this model is used to predict some unseen data, it's going to perform very bad. This is performing bad because उसका preparation नहीं हुआ. He's underfit to the data. उसने data ही नहीं समझा. उसने training data को ही नहीं समझा. तो test data को क्या समझेगा? वो पढ़ के आया ही नहीं है. ये underfit वाला किस्सा हो गया. ये इतना पढ़ के आ गया है कि रट ही चुका है वो. बुक को ही रट चुका है. बुक के बाहर अगर आपने इसको कुछ पूछा तो ये पक्का फेल होके आएगा लड़का. ये आंसर नहीं कर पाएगा. इसके लिए बेटर होगा कि हम एक ऐसा मॉडल जनरेट करें जो डेटा को मैप कर सके. He shouldn't cross all the data points, but he should be very close to all the data points. So this is a good fit model having a balanced bias and balanced variance. So it is like mid bias and mid variance. This is the case, and therefore you get a good model. So if there is no variation at all, बिल्कुल सीधी flat line है, the bias is very high. There is no flatness only in this line, so bias is almost zero. There is continuous dancing up and down. This is high variance. Here there is at least some territories are flat. For example, I can say this is a flat line, which is like, if I want to make tangents to my curve, simple geometry, tangents to my curve, at least I can make a few tangents. Can I make tangents here? I don't think so. But here I can definitely make few tangents. I can make one here, one here, one here. How many times slope is changing? Simple question. Here, how many times slope is changing? So no slope doesn't change. There's only one constant slope. One constant slope means very high bias. How many times here slope changes? Oh my God, so many times, Rocky Ji. So many times slope changes. No? That means your bias is very, very low. Bias is very, very low. On the other hand, variance is very high. So I want a balance. Sometimes the slope changes, I want that case. And sometimes slope changes means sometimes slope is constant. So sometimes when slope is constant, then bias is good or bias is average. Sometimes slope changes, that means variance is in the mid range. In this case, bias and variance both are in mid range because slope is changing, yes, but it is changing for a reasonable number of times, 3, 4, 5 times. It's not changing for so many times as much data points you have, right? So I hope this kind of helps you. Right? So Gantosh, your doubt gets answered.
Yes, sir, got it.
Yep, sure.
Sir, in your language, that as you always give the example that the student in that overfit case, that student in in the test scenario, that the student has gone that set of questions and is ratified, but when it is actually testing, so it is not, the questions is out of the syllabus, so he is not able to answer it. So that is how it is overfitting. And underfitting is that he has not in training data itself, it has not understood. So the test data he will not give that correct results. So we are trying to find out the in between there, which is best fit.
Perfect. You're finding something which is in between. That's the correct answer. Bilkul sir. Good. Okay, Kiran has a question. What about when data is a good fit on train set and not on test set? That's okay, no? So if it is not a good fit on the test set, that means you're going to get low accuracy and low bias. That's fine. So your model will need more data to get trained on. As simple as that. Means your training data is not a good resemblance of the testing data. As simple as that. So you'll have to add more testing data and retrain the model till the time it gives you a good fit. Simple. So we move on to the next to see what Vinod has asked. Yeah. So, Vinod, I want you to go ahead with your question so that because लोगों को भूल चुके होंगे अभी 2 घंटे हो गए आपके क्वेश्चन को सुने हुए. So we would have forgotten of what you have asked because the question is not something which we have dealt with in the entire scenario of our notebooks. You're getting me, right? So you can reframe your question. I'll not type anything. I have whatever I have understood your question very well. So I want you to describe in 2 minutes. Yes, Vinod, over to you.
Hello.
Yes, yes.
Can you hear?
Very clear.
Okay. The thing is, this is not a specific question. This is a scenario, and here I have been put into a particular scenario where the actual scenario is being described by an interviewer, that he was saying that there is a grocery shopping store, and there they are combining 2 or more products in a packet, and to identify which are the products and which are the good products that can be sold out together. Here they have put me into a scenario where they have given there is a let's say a category of customers. In a category of customers, there are housewives, or there are bachelor guys. Normally housewife is something that she prefers about the healthy food, and bachelors are prefer having chips and any fast food kind of a stuff. So let's say beer and chips, whatever example I have given right now. So here the thing is, when a housewife is not knowledgeable about the healthy food, and the bachelorette who is very much knowledgeable about the fast food or maybe chips and beer, that it can harm the body. So in this case, how the people will react, and is the model working, is the model working for us, and if it is not working, then how do we make it work? So that was a question. And for this we have given, I mean, I have given an answer that stating that we need to create a marketing model for targeting specific customer. And after creating a marketing model, we need to apply that marketing model in a different on a different days. Let's say in a particular day we are targeting a housewife, and let's say on a Wednesday bazaar we are targeting a housewives, and there we need to deploy such products which are normally housewife is I mean housewife will go for, like healthy foods. And we should target some other day, where maybe a, Saturday or a Sunday or maybe a Friday bazaar, where we can target customers like bachelorettes. They can go for a fast food or maybe a party kind of a food. So in this way, we can generate a model, and that both the models will perform very well, even if there are very less false positive and maybe true negative. So that was my answer. But it was like how to put this all into in the data science frame. That was my question to you.
Okay. Understood. Thank you. Okay. So just turn off your audio, Vinod.
Yeah.
Yes. I've turned it off. Yeah. Okay. So now, friends, you heard Vinod out again. Hmm? And so the scenario goes as ML model is, I'll just reframe the question what he has just said, because now even I understood his question a little better than what I understood previously. ML model is trained on two types of customers. So there is an ML model already got trained on two types of customers. Housewives who has been buying healthy food, and bachelors who have been buying fast food. We know where the interviewer confused him. Interviewer confused him, but if the customers coming to the grocery shop have housewives who are less educated and bachelors who are more health conscious, then the above model leads to a lot of misclassifications. That's right. Wrong solutions. So how to reduce a misclassification? The answer is actually very super simple. What your entire scenario is, Vinod, is what Kiran just asked about 2 minutes back on the chat. What I mean to say is the real time test data जिस पर आपका मॉडल टेस्ट हो रहा है, the real time test data should be a reflection. So there's nothing wrong if the ML model is doing misclassification. So the ML model is doing a misclassification because it is being trained on such a data which is not matching with the real time data. Okay? So the real time test data should be, first point, should be a reflection of the training data, which is not the case. Which is not the case. And at times it may not be the case. भाई नहीं मिला हमको जो डेटा हमारे पास पहले था. For example, if ML model was trained, suppose the ML model was trained from 1st Jan to 15th of March in the year 2020, and then you employed an ML model in the month of April in a particular grocery shop in the month of April or May. You know the lockdown was going on, and after the lockdown or during the lockdowns, people's buying habits have drastically got changed. People have shifted from loose food items to packaged foods, from packaged foods to healthy packaged foods, from healthy packaged foods to organic foods. ये जंप आया है लोगों में. जो हाई क्वालिटी पैकेज फूड्स खाया करते थे उन्होंने कुछ चीजें ऑर्गेनिक लाना शुरू कर दी. जो लोग लूज खाना खाया करते थे वो लोग पैकेज पर आ गए. जो लोग पैकेज खाया करते थे वो थोड़ा सा और ऊपर चले गए ऑन टू qualitative packaged food. They will not look at the brand also. Brand should be Hindustan Lever or ITC or Dabur. तो ही मैं खरीदूंगा तो नहीं खरीदूंगा. So there was a change. It means the real-time test data should be a reflection of the training data. And if it's not possible, and if it's not possible to, it's not possible to really have the test data always to be reflection of the training data, then in that situation, what are you going to do? Okay, so let me discuss that also. Okay, and if it's not possible to be so, then see, in this situation, what happens is, we have to go for something called as reinforcement. No, a bit too harsh. on this type of data. Go for online learning. So ये क्या होता है? जो हम लोग अभी पढ़ रहे हैं, नहीं, जो आप पढ़ रहे हो वो नहीं, वो अलग चीज है. जो पढ़ाई कर रहे हो उसको मत जोड़ो इससे. Online learning basically means that your model is going to get retrained on the test data, and its hyperparameters are going to get tuned depending upon the error it is generating. Meaning to say, so go for online. So I'll put it this way: go for online learning or walk forward approach. ये वो सुनना चाहता था आपका इंटरव्यू. सर आई विल गो फॉर ऑनलाइन लर्निंग और वॉक फॉरवर्ड अप्रोच. जैसे ही बोलोगे ना, तब आपको अगला बंदा इंटरव्यू पूछेगा ये वॉक फॉरवर्ड अप्रोच क्या होता है, जरा बताओ ना. मतलब उसको सुनना था, अब आपने वो वर्ड बोल दिया, अब आप एक्सप्लेन करो उसको. सो वॉक फॉरवर्ड अप्रोच गोज दिस वे. In the phase 1, you train your ML model. Phase 1, you train your ML model on the trained data. हाँ, क्रॉस वैलिडेशन यूज कर लो, मैं रोक नहीं रहा हूँ किसी को. क्रॉस वैलिडेशन तो टेस्टिंग की रिपोर्टिंग के लिए यूज करते हो ना. ट्रेनिंग के लिए आप ट्रेन डेटा यूज करते हो. यू ट्रेन इट ऑन 100% ऑफ ट्रेन डेटा. तो टेस्टिंग के लिए फिर हमको 20% निकालने की जरूरत नहीं पड़ेगी, क्योंकि हम क्रॉस वैलिडेशन करके टेस्टिंग कर रहे हैं. नाउ सेकंड, टेस्ट इट via cross validation. Suppose this reports a 90% accuracy. Your client is very happy. This is what your interviewer tried to ask you, because the old ML model was trained, but it was trained on data which is having educated wives and careless bachelors. So, but now the actual test data is like reverse. They are having less educated housewives, so unaware about things. They're unaware about healthy food per se. So test it via cross validation. This reports 90% accuracy. Okay. Next step obviously will be deploy. Correct. But now here the deploy actually. So this testing which you have done at this level here inside your development house. आप अपने घर पर मॉडल बना रहे हो, आप ही टेस्ट कर रहे हो. So we are now to look at what is called as A/B testing. So this is basically a part of A testing. So this is the test done. This is by you. This is an alpha testing. So once an alpha testing has been done, your phase 2 is going to be a soft launch where you're going to deploy the model. So soft launch would be the soft deployment. Hard deployment will be for everyone to use in the world. So deploy to कर दिया आपने model को proper server पर, but you're asking only your internal employees to use, or maybe some selected customers to use your model, and then to give you a feedback, to give you a review. So phase 2, do soft deployment. झिंडोरा नहीं पीटना है, सॉफ्ट होता है, झिंडोरा नहीं पीटना है, कर दो उसको, सॉफ्ट डिप्लॉयमेंट कर दो. ठीक है, किया सर. After the soft deployment of my model, what I will be doing is I will be obviously doing beta testing. So beta testing कैसा आएगा? नया डेटा आएगा ना आपको, जो आना शुरू हुआ था अब ग्रोसरी स्टोर में. Housewives who are less educated, bachelors who are more health conscious, ये आना शुरू हुआ. Okay, beta testing phase में पकड़े गए सब. Beta testing it again via cross validation, and this reports 82% accuracy. 82% accuracy. हाँ सर देखो मेरे मॉडल का accuracy कम हो गया. पेशेंस रखें. किसने रोका नहीं आपको मॉडल को रिट्रेन करने से? आप ट्रेन कर सकते हैं. So now create new data set. Create new data set. अरे सर फिर ऐसा तो वो ML इंजीनियर कंटिन्यूस सारा साल काम करता रहेगा, तो क्या लगता है आपको ग्रोफस का ML इंजन डिजाइन किया, उसको निकाल देगा बाहर? नहीं, उसको 25 लाख सैलरी पर रखा हुआ है. ग्रोफस का या बिग बास्केट का, डी मार्ट का, स्विगी ऐप का, इन सब का तो ML मॉडल कब का रेडी है? उन्होंने कोड भी लिख के रखा है जो वो अपने आप को रीट्यून करता है बैठता है. स्टिल दे हैव 15-20 ML इंजीनियर्स वर्किंग. व्हाट आर दे डूइंग? मॉडल तो इन प्लेस है ना, निकाल दो उनको बाहर. नहीं निकाल सकते क्योंकि उनके पास ब्रेन्स है. उनको निकाल दो तो ब्रेन कहां से लेके आओगे? कोड तो करके गए हैं वो लोग, ठीक है, कोड तो रन हो रहा है अपने में, लेकिन कोड में ट्यूकिंग करने के लिए उनका ही ब्रेन लगेगा. आप वहां से वो ब्रेन किसी से लेके नहीं आ सकते, right? So new data set will be old data set which you already have in phase 1. So old data set or original data set. I'll not use the word old, I'll use the word original data set. Plus you got some new data set right now during the beta testing. Yes, I got it, people came into my shop, so yes, I got some new test data during beta. Take them. These are going to have those people who are less educated housewives and more educated bachelors. So then again I have to train the model. Yes, you have to. Of course you have to. So the sixth step is going to be that it will be requiring retraining. Therefore, it's called as online. It goes on and on and on process. So you retraining. The seventh step is go to step 3. You again go back to step 3. So phase 2, वापस आओ. Yes, आपका old model will get replaced with the new model. Again, beta testing on real-time data. This will continue. When will this stop? Go to step 3 till, or I'll put it this way: repeat from step 3 till we get accuracy greater than the baseline model. So baseline model कब बनाया था भैया? वो तो phase 1 के पहले बनाया होगा ना आपने phase 1 जब बनाया तो उसकी शुरुआत कैसे की? Baseline model से की. Baseline model give you some accuracy. हाँ sir, 90%. No, 90% is the accuracy of the first model which you felt was appropriate and you give it to the customer. Baseline model accuracy could be 85%. Baseline model accuracy could be 89%. उससे ऊपर आपका accuracy आना चाहिए. That is a point which you stop. If you don't have a baseline model accuracy, then you will have an accuracy given by the customer. Customer usually does not give accuracy. उसको पता ही नहीं होता वो क्या देना है उसको. So repeat from step 3 till we get accuracy greater than the baseline model, or I'll give the choice also, or customer given specification. कुछ specification दिया होगा शायद customer के team में भी एक customer team, usually all customers, usually all the clients, none of them talk with the coders directly. None of them. That's the biggest blunder which they will ever do. They will always have an intermediate technical person in between called technical analyst. He's a technical business analyst who is going to do, and who are the people in the highest demand in the industry today, because these are the people who will actually understand the requirements from the client and properly communicate it to the developers. Otherwise, developers will make a mess of everything. Trust me. And I'm sure if anybody over here is doing a role of business analyst or a technical business analyst at a mid-level management position, he or she knows very well what I'm trying to talk about. Right? So, what has this question? Vinod. Yep. So Vinod, does this helps? Yep, Vinod, I'm asking. Oh, okay, sure. You'll answer in the chat, right? Cool. So this is what was expected, Vinod, by your interviewer in the near future. This is what I expected. And why is walk forward model? Because as you walk, you remember where you have walked. So you train first on, let's say, 1,000 records here. You got 100 new records in the beta testing. So your new data set is going to be 1,000 plus 100, 1,100. Next time, 1,100 plus 200, 1,300. Next time, 1,300 plus another 150, 1,450, so on and so forth. It goes on and on and on. So you are getting trained on new data. So you're getting a reflection of the data. So this can continue lifelong. Continue, Continue. Who's stopping it? Who's asking you to stop? Continue. All 99%, this is the way it works. It's not like एक बार ML model बना दिया उसको छोड़ दिया फिर आपने छोड़ दिया फिर वो तो it's going to always, as the time progresses, you are going to get poorer and poorer accuracy. That's naturally going to happen because the buying behaviors of people don't remain constant. It depends on time. It is seasonal, in fact. Summer season people will buy differently. Rainy season people buy differently. How many people are going to go to a shop and buy ice creams during rainy and winter season? Less people. Summer season, more people. So the buying patterns and buying behaviors always depend upon seasons, upon the environment conditions, upon the pollution levels, upon the earning capacity. These all things have not been taken in your data set at all. Is your data set taking the economic indicator? Is your data set taking the inflation cost? Is your data set for predicting of the model taking into the regard of where a grocery shop is? Is it in Kolaba or is it in Kolaba is a place in is a place in Bombay? So is it in Bombay? Is it in Hyderabad? Is it in Bangalore? Is it in Chennai? Or is it in a smaller tier 2 city like Nagpur? कहाँ है वो? So it depends where it is. Accordingly, the behaviors will change. So it has to get trained on local data once again. And that localization of data. So this even goes further where we train on localized data. So remember one thing, that a big basket app is not trained globally on India data. No, it is trained locally on local data. So तो बहुत complex model बनेगा, बहुत complex नहीं है, super complex model है. It is like a Spider-Man or Avengers series. इतना complex model है, जहाँ पर you have few maybe thousands of lines of code which has an if-else structure. If this area is Nagpur, tier 2 city, then this is the model is going to pick up. If the city is Bombay, it's going to pick up this model. So एक ही app पे multiple models काम कर रहे हैं for predicting or giving you predictions depending upon which locality you are in. It's very natural. How can you recommend the same basket in Punjab and in Nagpur? How is it possible? And in Bengal and Kolkata. In Kolkata, if you tell people to eat, or in South, if you tell people to eat chapati, they will say, "तुम क्या मेरे को क्या basket दे रहा है? गेहूं चावल मेरे को, I want only rice." But if you are going in North, they'll say, "रोटी तो होनी चाहिए, बिना रोटी के तो कोई खाना नहीं खाएगा वो." So you are suggesting a basket of things. That means the model is changing. So if the model is generically, then the Bombay बन जाएगा फिर. Only Bombay one generic model can work. Unless no part of the India generic model can work. Bombay, Delhi, Bangalore, 3 places generic model can work. Other places you have to have models which are specific to locality. Okay. So this also you should answer in the interview, that we could have localized ML models. Simple if-else structure has to be created depending on locality. We judge by latitude and longitude coordinates of what the primary locality is, and from that we apply the ML model, and the system keeps on training like this, right? Okay. Now, friends, I'm going to punch this file down to Rohan in moment I end my session in the next 2-5 minutes. So I hope the session was fruitful and useful. Okay. So example on nonlinear polynomial, how we have done any collab book on this. It's one of the same thing. Yes, we have done no linear model. The first Kavita, linear regression का जो model है, if you're giving me x which is having more than one feature, it is internally going to create a polynomial equation, y equal to m1 x1 m2 x2. So we have done ना linear regression में 2 examples थे, एक single variable था, एक multi variable था. So multi variable internally creates a non-linear polynomial, because polynomial will never be linear. It will always become non-linear only. Okay. Yeah. Right. So I hope this suffices you. Okay. Rohan has come up with something more. What is it? Okay. So Rohan has come up with the feedback form, and today, Rohan, you promised us yesterday that you're going to add a comment field. So did you?
Yes, sir. I've just added that one. Yeah.
Very good. Very good. So we should thank Rohan. He's fulfilled his promise. Very nice. Okay. So friends, so Rohan, were you also on the part of the session, or were you managing many other sessions? Were you part of the session? No. Prasun, we don't have a class on 26th. 26th is a complete off given by the management, so we don't have a class on 26th. Yeah, so it's completely holiday, and on the next week we are going to start with unsupervised learning. So I hope the session was fruitful. Intention was not of revision. Intention was to clear all your practical queries from your heart, from your mind, because otherwise, what happens? You just keep learning and do not know what to apply where, so this is all useless that way, right? Sure. So friends, we meet the next week then, and please fill in the Google form which Rohan has just supplied you, right? Yeah. Atnu, you're talking about the Kaggle link I shared yesterday? Okay. But don't start learning it, Atnu. Don't start learning it, Atnu, right now, please. Okay, I'm going to teach it formally when the right time comes. ऊपर से पढ़ लो उसको, लेकिन ज़्यादा मत सोचना मत उस पर. Don't take stress. Right. So, friends, thank you all, and I'll take your leave. Thanks all.